Hi guys, this is Ashkoil. Welcome back to Scalar. In this particular video, we're going to study about lead code problems. These problems will range from easy to medium to hard difficulty level. Along with that, we have covered a bunch of topics, be it greedy algorithms, be it trees, be it linked lists, be it arrays, strings, and a lot of different topics we have covered in these particular problems. Leetcode is considered to be a very important platform that can help us cover a lot of interview problems. Most of the companies have these rounds in which questions are being asked directly from Leetcode, so make sure you practice Leetcode problems very religiously and they can help you land your dream offer. Also, in this video, we have discussed the detailed approach. Along with that, we have discussed the code for that particular problem. So make sure you check this video till the end. It's going to be an extensive 4 to 5 hours long video that will give you a detailed analysis of some of the important questions present on Leetcode. Also, for more such amazing content related to interview preparation, related to data structures, related to cloud, related to system design, you can subscribe to this channel, like this video, and do comment in the comment box what all things you're not able to understand. We'll be more than happy to answer those. Hi everyone, this is Ashkoil, and in this particular video we're going to solve Leetcode problems. We're going to solve all levels of Leetcode problems based upon a mixed variety of questions. All will be trying to cover all the topics in programming, starting from arrays, strings, stacks, queues, dynamic programming, trees, graphs. So I'll try to cover the questions of most variety, and we'll cover the questions based on some questions will be easy, some questions will be of medium level difficulty, and some questions will be of harder difficulty. So this is going to be an immersive video. We'll be solving a lot of questions, and this content is going to be really very helpful. So if you are someone who is looking forward to prepare for your placements, or someone who is looking forward to prepare for your internships, so these Leetcode problems are very important from the point of view of your preparations. So make sure you watch this video till the end, and do let me know in the comment section if you have any feedbacks, any particular problem that you want more explanation or more clarity on. Would be more than happy to answer in the comment section. But let's start with the video with the first problem that I'm going to discuss today. That is basically, let's move up onto the problem. So the first problem of the day is sorting colors. So this is a problem that is of medium level difficulty on Leetcode. So let's try to understand what this problem says and how we can interpret this particular statement. So in this problem, we are given an array by the name of nums with n objects colored red, white, or blue. What you need to do, we need to sort them in place so that objects of same color are adjacent with the colors in order red, white, and blue, right? So we'll use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. So you must solve this problem without using any library's sort function. So what they have actually given to us is, let me just take up my notepad. So let's just discuss the first problem. Let me just erase this, right? So the first problem is sort colors. So when I say sort colors, what they're given is, we are given an array nums, and inside this array nums I have different colors. Let's say I have some red color, I have blue color, and I have green color. So all these colors represents 0, 1, and 2s. So that means my array is composed of numbers 0, 1, and 2, and they can be in any order. Like it can be 0, it can be 1, it can be 2, it can be 0, 2, 1, 0. Like they've given me this array as input, and they want me to sort the arrays according to this particular thing. Like all the zeros should come at the first, then all the ones should come, then all the twos should come. So this is what is expected as the output from me, and this is the input that they have given. So let's just try to look at this problem. Like they have mentioned these 0, 1, and 2 by the name of any color, but we'll be taking them as in general from 0, 1, and 2, and they have specifically mentioned you cannot use library function sort, right? So this is given in the question. Now let's try to see on how we will be approaching this particular problem, and how we can devise different methods, different ways on to how we can solve this problem, right? So the first method that comes into our mind is, let's say we are given an array that has numbers and we need to sort them in ascending order. So basically, if all the zeros are at the first, then ones, then twos, so that means we are trying to sort it in ascending fashion. So simply, like, the first and the most common brute force approach that comes into our mind is sorting the array, right? So I can use any of the sorting techniques, be it merge sort, quick sort, any of the sorting techniques, or I can use the internal SQL library function sort, right? So this can give me the result in complexity of O of n log n, right? So this is very noob. So why they have given this question in the medium bracket, even if we can solve it using a sort function? So that's why they have specifically mentioned that you can't use this sort function to solve this particular problem, right? So there might be some better way or something better in which we can solve this particular problem. So let's come on to the second approach. What can be done? So let me just take an example of the array, right? Let's say I have 0 1 1 0 1 2 1 2 0 0 0 1. So let's say this is the example. This is probably the example that Leetcode has taken to explain the test case. So for this particular example, what I will be doing is I'll apply something known as counting sort. So when I say counting sort, that means I need to count the number of zeros, I need to count the number of ones, I need to count the number of twos. So if I go and count the number of zeros in this particular array, by simply we can take a variable count 0, and as soon as we encounter any 0, we'll do count 0 plus plus. Similarly, we'll do count 1 plus plus, count 2 plus plus, and we'll store the values of these three numbers. And like once we have this count, let's say how many zeros are there? 1 2 3 4 5. So there are 5 zeros. How many ones are there? 1 2 3 4 5. There are 5 ones. How many zeros are there? 1 2 how many twos are there? There are 2 twos. So this is the particular statement. Once I have this count, what I will do is inside this particular array, I'll again run a loop, and for the first 5 digits, I'll replace each and everything by 0. This will be replaced by 0 0 0 0. For the next 5, I'll be replacing them by 1 1 1 1 1, and for the next 2, I'll be replacing them by 2. So I'll be getting the output, but let's discuss what would be the time complexity for this particular approach. So for this particular approach, the time complexity will be O of n plus O of n. Why O of n plus O of n? Because we are traversing the array twice. First, when we are counting, right? So O of n time complexity is used when we are counting the number of elements, and O of n time complexity is used when we are filling the array again, right? So it comes out to be O of 2n. So we can say it is close to O of n again, but still we'll have to traverse over the array twice. So that means it can be improved a little further, right? Space complexity wise, it is still O of 1. We are doing it in place, right? Let's see if there's any better approach available. There is something known as Dutch national flag algorithm, right? There's something known as Dutch national flag algorithm. So why this algorithm is called Dutch national flag algorithm? Because in Dutch national flag also the same 3 colors are there, right? The same 3 colors that we're using, we need to sort these colors. So these 3 colors are there in the Dutch national flag. So we'll see how this algorithm actually works. So what will be like, let me just take the same example of that array, and then we'll try to see how this approach works on that. So the array that I took from the Leetcode example was 0 1 1 0 1 2 1 2 0 0 0 1. So this is the input that is given to me. So what happens in the Dutch national flag algorithm is I'll take 3 pointers. These pointers will be first, middle, and the last pointer, right? So the first will be pointing to the first element of my array. The middle will also be pointing to the first element, that is the 0th index of my array, and the last will be pointing to the n minus 1th index. So let's say the size of this array is n, and this is the initial index, that is 0 1 2 3 4 5 6 7 8 9 10 11. So let's say this is 11 or 12. I might have missed out something. 2 3 4 5 6 7 10 11. Okay, fine. So this is the particular case of this particular algorithm. Like I have initialized first equal to 0, I have initialized mid equal to 0, and I have initialized last is equal to n-1. That is the size of this particular array. So according to Dutch national flag algorithm, what I will be doing is I'll be starting up with mid. I'll be moving this mid over this entire array starting from the 0th position, and will be doing certain operations as soon as this mid encounters something, right? So there can be three things. Whenever, like, let me name this array as nums. So when the nums of let's say mid becomes equal to 0, when the nums of mid becomes equal to 1, and when the nums of mid becomes equal to 2. So these are the three cases that we'll have, and we'll be doing the things based upon these. So when the nums of mid is equal to 0, what I will be doing is I'll simply swap the element which is at the first index and the middle index, right? So what I'll do, I'll swap the element which is present at nums of first and nums of mid. Along with that, what I will do, I'll do first plus plus. I'll increase the first index and I'll increase the middle index as well, right? If at all I have encountered mid is equal to 1, so in this case I'll simply do mid plus plus. There's nothing to be done, right? And for 2, if at all 2 comes up, I'll again use swap nums of first with nums of middle with the nums of last, and I'll be doing last minus minus. I'll decrease the index. So now let's consider this as in our example. So now mid is at the 0th location and we have 0 here. So first will be swapped by nums of first will be swapped by nums of mid. So this will be swapped by this. So nothing is going to happen. We'll simply do first plus plus and mid plus plus. So first also points to here and mid also points to here. Now as soon as we go ahead, we check out that mid is equal to 1. So now when mid is equal to 1, what we simply do, mid plus plus. So mid will go from here to here. Again there is mid, nums of mid is equal to 1. Again we'll do mid plus 1, mid plus plus. So mid will come here. Now we encounter nums of mid is equal to 0. So in that case we will be swapping this with my first index, right? So this will be swapped. Here it will be 1, here it will be 0, and we'll be doing first plus plus. First will come here and my mid will also increase. Mid will come here. Again it is 1. Simply I'll move forward. Now it comes out to be 2, right? So now when mid is equal to 2, what I need to do, I need to move the swap this last index with this particular case, and along with that I'll decrease the value of last, and last will point to this now. And as soon as we'll do the entire process on this particular array, so we'll have a sorted array of this particular fashion, where all the zeros will be there in the first, all the ones will be there after this, and all the 2s will be there after this. And we'll have to do these entire steps for how long? Until and unless this mid is less than or equal to my last index, right? And this thing basically will have all the zeros ranging from 0 to first minus 1 index, all will be zeros. Then last to n minus 1, all will be 2s. and in between everything will be ones. So in this way my array will be sorted, and this, for this particular approach, the time complexity will be O of n, but the best part is we'll be traversing it single time. In the last case we were traversing it 2 times, we'll be traversing it single time here. Space complexity is again O of 1. So this is basically how we'll be solving this particular problem. Now let's quickly move on to the code and see if we are able to solve this particular problem, or if we are able to submit this particular problem on Leetcode. Right. So let's just see the interface of Leetcode. We are there on the question. So what I need to do is, firstly I need to calculate the value of n, that is the size of this particular vector that is given, vector of int nums dot size. Right, after this I'll take 3 variables. Let me take it as int first equals to 0, int mid equals to 0, int last is equal to n minus 1. Right, now we need to put it in a loop. This loop will run until and unless this mid is less than or equal to last, right? And we'll check for the different values of mid. We'll put the if else statements. If the nums of middle is equal to 0, right, this is going to be one case. So what we'll be doing in this particular case is we'll simply swap nums of first and nums of mid. We'll swap, right, and we'll do first plus plus and mid plus plus. Both the indexes will be increased. This is the first thing. Now else if, we'll go to the else if condition. Else if, what we're going to do, else if the value of nums of mid is equal to 1. So when it comes equal to 1, so what we need to do, we don't need to do anything, we just need to do mid plus plus, right? And else if nums of mid is equal to 2. So what we're going to do in this case is we are going to we are going to swap again. What we're going to swap, nums of last and nums of middle. Along with that we need to decrease the value of last, that is last minus minus. So basically this is what we are going to do in this particular question, and I hope we are done. The return type is void, we don't need to return anything, and the array should be sorted internally, that is in place, without any library used. And this algorithm that we're using here is Dutch national flag algorithm. Let me just try and check if everything is all right, then we can submit this problem. If mid is less than middle is the last, 0, so first middle, it's fine, I guess. Let's try to run the code. Okay, there is some, I guess there's, yeah, this is missing. Okay, let's just run this. Yeah, so the output that we have in this particular question is 0 0 1 1 2 2 for this particular test case, that is unsorted arrays of 0 1s and 2s. The expected output is also similar to the output that we have, and I hope if we submit it we get the correct answer. So yeah, this is a success. We will be able to solve it in this way. And yeah, this was all for this particular question. Let's move on to the next question. So the next question that we're going to discuss is basically a rotate image question. It is also rated as medium level question on Leetcode. So what we are given in this particular question is we are given an n cross n 2D matrix, that is a square matrix that represents a particular image. You need to rotate the image by 90 degrees, that is in the clockwise direction. what they're actually going to say is like, also they have mentioned one more thing, that you have to rotate the image in place. That is, you don't need to create an extra matrix, or you need to do it in place only, which means you'll have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. ठीक है जी. So we'll be doing it in this way. We are given an example. We are given a matrix 1 2 3 4 5 6 7 8 9. If I rotate this matrix, let's say 7 4 1 to 90 degree clockwise. So 7 4 1 90 degree clockwise will be in this way. 7 4 1 is in this way. 2 5 8 90 degree clockwise will be in this way. So it's in this way. Then again 3 6 9 90 degree will be this way. 3 6 9 90 degrees in this way. So all like this is basically how we are rotating this image in clockwise direction by 90 degrees. This was for 3 cross 3 matrix. Now this is for 4 cross 4 matrix. 5 1 9 11. If rotated clockwise by 90 degree will come, like 5 will come here, 1 will come here, 9 will come here, 11 will come here. Similarly 2 4 8 10 will be like 2 will come here, 4 will come here, 8 will come here, 10 will come here. So in this way we need to solve this particular problem. Now let's see what will be the approach for this particular problem, and then we'll come on to the coding part. So when I say this particular question, we need to rotate, right? Rotate image question. So one thing that we can do is, let's say we are given this particular matrix 1 2 3 4 5 6 7 8 and 9, and we need to come up with the solution of this form: 7 4 1 8 5 2 and 9 6 3. So this is the output that we want, this is the input that we have. So the first approach that normally comes into our mind, or when the interviewer asks us, so we should give this particular approach. So the first approach is basically brute force. What I'll do is, I'll say that I'll take another empty matrix of the same dimensions. Let's say if this is 3 cross 3, I'll take one 3 cross 3 empty matrix. I'll create a new matrix and I'll put this row as my column in the new matrix. So 1 2 3 will be written as here, 4 5 6 will be written as here, and 7 8 9 will be, the last row will be transformed into the first column. So it will be 7 8 9. So this approach basically, the time complexity of this approach is O of n square. The space complexity of this approach is O of n square again, right? So why the space complexity is O of n square? Because we are creating a whole new matrix, but this was not allowed as per question. So what we need to do, we need to do this in place. So if I say we need to do this in place, so how can this be done? This can also be done, like this is a very peculiar approach. So you all might have heard of transpose, right? So transpose of a matrix. So when I say transpose of a matrix, let's say we have a particular matrix of this form: 1 2 3 4 5 6 7 8 9. So when I take a transpose of this matrix, it comes out to be like this. Row becomes columns and columns become rows. So this will be 1 4 7 2 5 8 3 6 9. So this will be the transpose of my matrix. And what is the output that I'm looking forward from this matrix? The output I'm looking forward from this matrix is something like this. So what is the output that I'm looking forward from this matrix? It's 7 4 1 8 5 2 9 6 3. So if I take the transpose, I get this particular matrix. So how we can change this particular transpose matrix to obtain this? So to do this, what I'll do is I'll reverse each row. Reverse each row. What I need to do is I need to reverse each row. Like 1 4 7 will be reversed as 7 4 1, 2 5 8 will be reversed as 8 5 2, 3 6 9 will be reversed as 9 6 3. Right? So this is the approach that we are going to follow. The first thing that we will be doing is we'll be transposing our matrix. Transpose is basically we'll convert the ith and jth index of a matrix to jth and ith index of a matrix. So the rows are turned into columns and columns are turned into rows. After this, what we are going to do is we are going to reverse each row of the transposed matrix. ट्रांसपोज मैट्रिक्स का will be reversing each row. This is the second thing that we are going to do. Now let's move on to the code part and see if we are able to submit this particular problem. Right, so this is basically a rotate image question. What we are given in the input is we are given a vector of int in the form of matrix. So first thing that I'm going to do is I'll calculate the size of this matrix, that is int size, int size is equal to matrix dot size. Right, after that I'll run two for loops. Int I is equals to 0, I less than size, I plus plus. Then I'll run another loop for int j is equal to 0, j less than I, j plus plus. What we need to do is we need to swap this matrix of I comma j with matrix of j comma I. Right, once these are swapped, the next thing that I'm going to do is I need to reverse each row. So how I can reverse each row? For int I is equals to 0 to I less than size, I plus plus. Thing I'm going to do is I'll use the inbuilt function, that is reverse matrix dot begin. Basically the reverse function that will reverse the array. Like this matrix of I stands for first row. Like I'll iterate for all the rows and finally we'll get the output that we are looking forward to. It will do m of I end. Right, so this is basically the approach and I hope it should be correct. Let's check once by running the code. Okay, so they are expecting on line number 52, line number 16, I think we have missed one semicolon. We missed one semicolon. Yeah, now I hope it should be fine. It is matrix. Okay, yeah, so we are able to get the answer. Like for the matrix 1 2 3 4 5 6 7 8 9, we have the output 7 4 1 8 5 2 and 9 6 3. This output is equal to expected output. Let's try to submit and see if we are able to solve this particular problem. I hope this problem is clear to you. Right, so let's see if it gets submitted. So we're able to submit this problem and yeah, we're done with this problem. So I hope this approach is clear. Basically we need to first take the transpose and then we need to reverse each row. So this is the approach that you need to tell to the interviewer so that you can pass your next interview round. Now let's move on to the next problem. So the next question that we're going to discuss is basically find the duplicate number. It is also rated as one of the medium level questions on Leetcode. So what will we be given in this question is we'll be given an array of integers, let's say nums. It is containing n plus 1 integers where each integer is in the range of 1 to n inclusive. Right, 1 and n both are inclusive. There's only one repeated number in nums. You need to return this repeated number. You must solve this problem without modifying the array in nums and uses only constant extra space. Right, so we can't use an extra space. We can't modify the array. Let's say we are given an example with the following numbers 1 3 4 2 2. So it is having n plus 1 integers. Like let's say it is having 5 integers, right, and 2 is repeated, so we need to return duplicate number. Similarly in this we have 3 repeated, so we need to return 3. Right, so let's just see the approach on how we can approach a similar kind of a problem. Let's say we have the example that is they have given 1 3 4 2 2, right? So the example that they have given is 1 3 4 2 2. So there are n plus 1 integers, right? So n plus 1 integers, and we need to return the repeated one. So the first approach that comes to our mind is basically we can sort the array, right? The first and the most obvious approach, that is sorting the array. So once we sort the array, we'll be getting something of this sort, that is 1 2 2 3 and 4. So this will be the sorted array, right? So inside this sorted array, what we'll check if at any index array of I is equal to array of I plus 1. So this particular condition will give us the repeated number. But again, what will be the time complexity in this case? O of n log n, because the best sorting technique, if we'll apply, let's say merge sort or quick sort, then also it will be n log n. So this will be the time complexity. Space we are using constant. Second approach that comes into our mind when we think of this particular problem is hash map based approach. So when I say hash map based approach, so what is there in this hash map based approach is, like, let's say you are given this particular array 1 2 2 3 4, and you can create a frequency array, right? You can create a frequency array of the same size, and for each number you can increase the frequency. Let's say 1 is coming for the first time, we like all are initially represented by 0, like they are initialized to 0. Once we will traverse this particular array, that is the input array, and for every element we'll increase the count, right? Like first, for example, we are getting 1, so we'll increase the count of 1 to 1, that is frequency of 1 is 1. Then we'll go on to 2, we'll increase the count of 2, that is we'll increase it to 1. Again, we'll see when we move on to the third element, 2 is already present in our frequency array, hence we will find out that this is the repeated number. But what is wrong with this approach is basically we are using this extra space. This extra space that we are using, this should not be used, right? So is there anything else that can help us solve this particular problem? Is now let's try to see what is that approach. So that approach is basically similar to how we are finding. That's, you can say it's a linked list cycle approach, Floyd-Warshall, right? Cycle based approach. So we'll be using this particular approach to solve this problem. Let me just take a little larger example for this. So when I say a little larger example, let's say 2 6 9 5 3 9 8 9 7 1, right? So this is the particular example. Let's just 2 3 4 5 6 7 8, I have indexed also. So we'll start from the first number, that is 2, right? Let's just try to traverse over this array in such a way that it let's say, right, so I am here at the 0th position. We'll start from 0th position, that is 2. So here is 2. Now we'll go to the second index and see which number is there. We have 9. Then we go to the 9th index and see which number is there. We have 1, so we'll move on to 1. Then we go on to the first index, it is 6. We have 6. Then we go on to the 6th index, that is 8. We have 8, right? Then we go on to the 8th index, that is 7. We have 7. Then we go on to the 7th index, that is 9 again. So this is something that is formed, right? So it looks something similar to a cycle, right? Let's say we are coming back to 9. So this shows that 9 is repeated. Like we are coming back to 9. That exactly means that 9 is repeated. So how we'll calculate which number is repeated? So this is basically what we'll do. Firstly, just forget everything and see we have made the structure, right? Made a structure similar to this. Now what we'll do is we'll take 2 pointers. So these pointers are known as slow pointer and fast pointer. So initially both the slow and fast pointer are pointing to this 2. right? So what is the property of slow pointer is slow pointer will move in a single move by one in one particular direction, and fast pointer will move at a speed that is twice that of the slow pointer, right? If slow takes one step, fast will take two steps. According to our logic, if fast and slow are here, so after first step slow will be here and fast will be taking two steps, it will be here. After second steps slow will be here, right, and fast will be going to here. Fast will be here. After that slow will be here, fast will be here. After that slow will be here, fast will be here, then slow will be here, and again fast will be here. So if slow and fast pointer meets, that means there is a cycle and there is a repetitive number. Now we need to check which is the repetitive number. So what we'll do is the point where slow and fast pointer meet, we'll move the fast pointer from here to the first number, and then we'll move both of them at the same speed. Fast pointer will also move at the same speed, slow pointer will also move at the same speed. If both of them will move at the same speed, after moving at some particular distance, they will meet at a number 9. So you will say how they will meet at a number 9, and we'll get to know that this is a repeated number. So the valid mathematical proof for this, let's go and see how this thing happens actually, right? Then we'll move on to the code part and on how we have seen this approach. Let's say we are having this particular thing, right? This is a point where they're initially meeting. Both slow and fast pointer are meeting initially at this particular point. So let us consider they start from here, both slow and fast. Let me consider this distance as A, this distance as distance B, and this distance as distance C, right? According to what we have taken, the assumption is the distance that is traveled by slow will be exactly equal to twice, right, the distance that is traveled by the fast. Let's say if they are meeting here, slow and fast are meeting here, so if slow will be moving covering the distance A, then it will be covering the distance B. In the meanwhile, fast will cover the distance A, it will rotate over this entire circle, it will go round and round, and it will again come at this particular point. So basically the distance that is covered by fast is twice the distance that is covered by slow. Everybody of you agree? So what is the total distance traveled by slow if I calculate? So slow will move from this to this, that is A. Then let's say slow covers some m rounds around it, or it can just simply have this B distance. So let me say that it covers m rounds across this particular circle, so it will be m of B plus C and this B distance again. So this is the total distance that is traveled by the slow pointer. Similarly, what will be the distance traveled by fast pointer? Let's say fast pointer will also cover this A distance, plus let's say fast pointer makes n rounds, so n of B plus C and again B. So this is the distance that is traveled by the fast pointer. If we'll solve this maths, what will happen? It is 2A plus 2m into B plus C plus 2B is equal to A plus B plus n of B plus C. So after solving this, what we get is we get something like A plus B is equal to n minus m of B plus C. So this n minus m is basically the n are the number of rounds that B takes, basically the fast pointer takes, and m are the number of rounds that slow pointer takes. So this will basically be constant. Let's take it as gamma. So A plus B is equal to gamma times B plus C. Let's say for different values of gamma, let's say for gamma is equal to 1, what will be the case? A will be equal to, A plus B will be equal to B plus C. So it will be A equals to C. That means this distance will be equal to this distance. That's why if I move this fast pointer here, it will automatically cover this distance, and both of them will be same, and they will meet at this particular junction, right? You will say that what if I take the value of gamma as 2? So if I take the value of gamma as 2, what will happen is a plus b will be 2 times b plus c. So what will this mean? It will be a is equal to 2b plus 2c minus b. It will be a is equal to b plus c, right? So what does this b plus c suggest? So if the distance covered, like a is equal to p plus c, so this means that this p plus c means the extra number of rounds that are around this particular circle. So we can consider them to be there's no significance of them, because we just need to find that they need to meet at this particular point. So a will always be equal to c, that is they are going to meet at this particular point, and this particular point will be our duplicate number, right? So this is the approach that we are going to follow. I hope you have this approach is clear to you. If still it is not clear, then I recommend you to watch this video once again and try to dry run this approach on your own using a pen and a paper, right? Now let's try to submit this problem on Leetcode. So you have to find the duplicate number. What we did in our approach basically is we took 2 pointers, that is a slow pointer. Slow is equal to nums of 0. Both of them started from the 0th. Int fast is also equal to nums of 0. After that we run a do while loop. So inside this we'll check until and unless slow is equal to fast, right? So we'll run a while loop for slow to fast. So what we'll do is we'll move slow by 1 and fast by 2. So the speed of fast will be twice that of slow. So slow will be equal to nums of slow, right? And fast will be equal to nums of fast. That is, it is moving by 2 at a time, right? So after this, like we are at a condition where both slow and fast are meeting at one common junction, right? After that, what we did is we took the fast pointer from here and we started up fast from the first nums of 0. So what I'll do here is I'll put fast is equal to nums of 0, right? After that, we'll move both fast and slow at the same pace, and they will automatically meet at the common junction, that is our repeated number. So what I'll do is I'll run this while loop while slow is not equal to fast. Slow will be equal to nums of slow and fast will be equal to nums of fast, right? So after that we just need to return this slow and we are done. So I hope this approach is clear. It might be look a little typical to you, but it's something that we have used of linked list concept, right? Now let's try to submit. Not linked list concept, but this approach we have taken from how to find a cycle in a linked list, right? So this solution is accepted. For this particular case, we are getting 2 as the output, that is 2 is the repeated number. Let's try to submit and see if it is submitted. Right, we have been able to successfully submit this problem. So that was it for this problem. Let's move on to the next problem. Hi everyone, welcome back to another question. In this video, we are basically going to discuss a new problem, that is add new 2 numbers. So what you're given is you are given 2 non-empty linked lists representing 2 non-negative integers. So this is the condition that is given. The digits are stored in reverse order. Basically, the digits that you are given, they are stored in reverse order. Each of their nodes contain a single digit. Add the 2 numbers and return the same sum as linked list. So you will be given 2 heads of 2 linked lists, and they will be representing 2 numbers. present in reverse order, and you need to add these two numbers. You need to add these two individual elements of linked list separately, and then you need to return the answer in the form of head of the linked list only, right? So let's see with this with an example, and then we'll try to see how we can code this better, right? So let's take an example where we have something of the sort. Let's say we have 4. Let's say we have 4, we have 6, we have 2, and we have null. Second, like we have this linked list L1, we have this linked list L2. In this we have 2. Let's say we have 8, we have again 8, and let's say we have 1. So we are given this L1 and L2 that points to the head of linked list L1, L2 points to the head of linked list L2, and we need to return our result. So the result would be in such a way that these numbers are given to us in the reverse order as per the mentioned. So the original numbers will be 264 and 1882. So when I add these two numbers, so it will be 4 plus 2 6, it will be 8 plus 6 14. So 4 will be here and 1 will be given as carry. So 8 9 10 and 1 11, 1 and 1 will be again carry. 1 and 1 when added will give us 2. So the answer is going to be 2146. So we need to return, let's say we need to return result, and the result should look something like 6 4 1 and 2. So this is something that I want to return. I want to point this result to this head of the answer, and I need to return this result. So this is something that we're looking forward to in this particular question. So for solving this question, let me take a dummy node. Let's say I'm taking a dummy node D. So this is the dummy node, and let's start pointing it to let me just take this as L1, this as L2. We'll take two variables, sum and carry, right? So we'll try to add individual L1 and L2. We'll first of all I'll go and check if L1 is empty or L1 has something. So if L1 is not empty, I'll go to L1 and I'll add L1 and L2 together. So when I'll add L1 and L2, I'll put that thing in the sum. So 4 plus 2 comes out to be 6. So I'll have 6 in the sum, and also I'll make a new node with 6, that is sum. I'll insert into this list, and I'll point this to this, let's say it's pointing to temp, and I'll point this dummy node to 6. Now temp will move on to this 6. As of now, this is what is happening till now, right? And carry is 0 in this case, right? So what we're going to see in the next, like we'll move L1 one step forward, we'll move L2 one step forward. Now again we'll once 6 is written here, we'll remove 6 from here, and it again turns out to be 0. So now we'll add 8 plus 6. We'll check if L1 is empty or L2 is empty. As soon as any one of them is empty, we'll will not do anything, but they are not empty, so we'll add 8 and 6. Adding 8 and 6 will give us 14. So we'll put 14 in the sum, right? And we'll create a new node, and inside this new node, what we'll put, we will be putting sum modulo 14. This is something that we'll put in sum modulo 10. So what is the sum now? It's 14 modulo 10, that is 4. So we're going to put 4 in our new node, and we'll point this temp to this, and inside our carry, what we are going to put inside our carry, we are going to put 14 divided by 10. So when I say 14 divided by 10, it gives out to be 1. So my carry becomes 1 now, right? So now again 14 is gone and 14 turns out to be 0, right, with carry 1. So now this carry is also there, right? Now this carry is also there. So what happens is, as soon as I move L1 to here, L2 to here, now while calculating sum, I'll add this carry also, right? Once I'll add this carry, so it becomes 8 plus 2 plus 1. So it is 11. So 11 is there in the sum, carry becomes 0. Now what I'll be putting in the next node? In the next node, I'll be putting sum modulo 10, right? So that is 11 modulo 10, that gives 1. So I'll be putting 1 here, and in the carry what we'll put, again 11 divided by 10. So 11 divided by 10 is again 1, so I'll put 1 in the carry again, right? As soon as this is done, so we'll put sum is equal to 0 again, and we'll move L1 and L2 further. Now L1 is not there, right? So we'll not take L1 now, but L2 is there, and along with that a carry is there. So carry is 1, L2 is 1. When I'll add L2 and L1, when I'll add L2 and carry, so it comes out to be 2. So I'll have 2 in the sum. So what will be there in the carry? That is 2 divided by 10. 2 divided by 10 and 2 modulo 10. 2 modulo 10. So 2 modulo 10 will give me 2 again. So I'll add 2. I'll move the temp here. Earlier also I'll move the temp here, and 2 will be pointing to 2. I'll create a new node and I'll add 2 into it. 2 divided by 10 gives me 0, so I'll make carry equal to 0. So in this way, now my L1 is also empty. Now like till how long I'll have to run this loop? Either we'll check for L1 whether it's empty or not, we'll check for L2 whether it's empty or not, and also we'll check for carry if it is empty or not. If there is only carry left, then also we'll add only carry to our new we'll make a new node and we'll put that carry into our new node and we'll point that to null. So that is basically what we are trying to do in this particular question. We'll point this to null at the end and we'll return the dummies next. Dummy ka next is basically the head of our new answer, so we'll return dummies next as the output. So this is going to be the approach. Talking about the time complexity, so it will be O of M or N, the length of the longer linked list, right? If it's L1 or L2, so it's basically the time complexity goes according to that. Also, let's now discuss the code part. Like if we are trying to code this particular solution, then how this is going to actually work and what all things we need to do. Basically, we will be doing the same what I have explained to you here in the explanation part, right? Now let's move on to the code part and see how we can code this. So basically what we are given L1 and L2. So L1 and L2 points to the head of two linked lists, L1 and L2. So firstly, I'll create a dummy node as per I have explained to you. It's list node. Dummy is equal to new list node. Then what I'll do, I'll create a temp variable that is pointing to this dummy. So this temp will be taking forward when we add a new node to our result dummy linked list, right? So temp will point to dummy. After that, we'll initialize a carry variable which is equal to 0, right? So we'll run this while loop until and unless we discuss about 3 conditions. Firstly, L1 should not be equal to null, or L2 should not be equal to null, or carry should not be equal to null. So these 3 conditions these should satisfy until and unless this loop will run, right? So int sum is equal to 0. Initially I have initialized the sum is equal to 0. Its value will be what we are what we'll be going to see from L1 plus L2 plus carry, right? We are going to do this. So inside this we'll check 2 other conditions. If L1 is not equal to null, until and unless L1 is not equal to null, what we'll do, we'll add the value of L1 in sum is equal to L1's value, right? And then we'll move on L1 further. L1 is equal to L1's next, right? Again, if L2 is not equal to null, then what we'll do, we'll do sum plus equals to L2's value, right? And we'll do L2 is equal to L2's next, right? So we have done these 2 things. After that, what I was doing is I was adding the value of carry in sum. That's the 3rd thing, right? And what was the value of carry? Carry was equal to sum divided by 10. What after this? We were creating a new node, list node, in which we are storing the answer. Node is equal to new list node. And what will this list node have? List node will be having sum modulo 10, right? Why this sum modulo 10? Because like we saw that the last part was like, let's say we have 14 as the sum, so 4 will be there in the list node and 1 will be given to the carry. So we have given carry as sum divided by 10 and the number in the list as sum modulo 10. Next thing is, we'll be moving apart our temps next is equal to this node that we have created, and then we'll move on temp further. Temp is equal to temps next, right? At the end, what will return? Will return dummies next, and we are done. This is basically what we have done and what we have understood in that particular solution. Let's try to run this code and see if it is working. So we were to create list node here. I think everything else should be fine, or if there is some typo. Okay, so it's val, not value. Okay, so for this particular case, like 2 4 3 5 6 4, we should have 5 plus 2 7, 6 plus 4 10, 0, 1 is carry, 4 5 6 7 and 8 should be the answer. 8708 is what we are getting as the reverse number. So exact answer should be 807, but we need to return the reverse, so it is 708. So let's try to submit and see if it is submitted. Yes, we are able to successfully submit this problem, right? So that was it for this particular video. Let's move on to another question. So we're going to see the next question, that is balanced parenthesis. So in this particular question, what we are given is, the question goes something like this. Let's read the statement of this question from Leetcode, and then we'll come on to the discussion part, right? So the question says that you are given a string S which contains characters, open brackets, parentheses, then there is curly brackets, and then there are square brackets. Determine if the input string is valid. So we need to check if the input string is valid. So what valid string is? A valid string is a string with if open brackets must be closed by same pair of brackets, also open brackets must be closed in the correct order. So we can see some of the examples that are given. Some of the examples given are basically 2 open brackets true. This is opening bracket, closing bracket, opening bracket, closing bracket, opening bracket, and corresponding closing bracket. Here we are getting a false because they are mismatching pair of brackets. So let's just deep dive into the problem and see what they are trying to say. So let us take an example. Let's say we are given something of this sort. Right, let's say I'm given a string S of this sort, and I'm given a string S of, let's say, this sort. So in this particular string, you can see for this corresponding input string, opening bracket, I have this closing bracket. For this opening bracket, there's an opening bracket. I have this corresponding opening closing pair. I have this opening closing pair, and this opening and closing pair. For this particular case, I have this opening and closing bracket. I have this opening and closing bracket, and this is left. So there's no opening pair for this particular bracket. So this case is not valid. And this is a valid case, right? Similarly, let's take some more examples. Let's say you are given a string of this particular form in which it goes something like this. So in this particular string, you can see for this particular opening bracket we have a wrong closing bracket, so the pair is mismatching, hence it is not a valid parenthesis, right? Third case that we're given here is let's say we are given something of this particular sort. So in this particular case, although we have this pairs which are correctly opening and closing, but they are mismatching, right? For this particular opening bracket, we have this corresponding bracket. This is a mismatching pair again. Hence, we will say that this is also not a valid parenthesis. So what should be our approach to solve such a problem? Let's just go and see that. So for such a problem, we'll be solving it using stack as a data structure, right? So let's say we are given a string of this particular format. Let's say we are given something like this. Right, so we're given something like this. We have the stack, let's say S. Stack is basically a LIFO data structure. That means the element which is added at the last, it will be removed at the first. So it's basically a last in first out data structure. So we'll go on and see and traverse the string. So the first element we see in the string is an open bracket. As soon as we see an open bracket, so which all are open bracket cases, it can be either square bracket, it can be the curly bracket, or it can be either parenthesis. And what all cases are there for the closed bracket? So corresponding to these, we can have a closing pair, right? So whenever we see an opening bracket, so we'll push it into stack, right? Whenever we'll see a closing bracket, we'll have two things. Firstly, we'll check if the stack is empty or not. Secondly, we'll check if there's a corresponding opening bracket available. Right, so for this particular case, let's say we have started traversing the string. The first element of the string that we get is an opening bracket, so we put that into our stack, right? And we move on. Second is also an opening bracket, we put that into the stack and we move on. Third is also an opening bracket, we put that into our stack and we move on. Fourth is also an opening bracket, we put that into our stack and move on. Next we come across a closing bracket. So now we have a closing bracket. We'll go and check if our stack is empty. No, our stack is not empty. So what we'll do, we'll pick up the topmost element of my stack and I'll compare it with this, whether they are a matching pair. Yes, they are a matching pair. So we'll move on to next. Again, we'll check for this particular case, we'll check the top of the stack. Now we have this opening bracket, we'll check, we'll match them. Yes, it forms a pair, right? Now we'll move on to the string again. We have third pair of closing bracket, that is a square bracket. We'll go and check in the string, we'll remove this from the stack and compare. Yes, it's a matching pair. Again, we'll move on to our string, we'll see, we'll again remove from the stack, we'll compare. Yes, it's a matching pair and we are done. So now the string is empty. As soon as the string is empty, we'll check if our stack is also empty. As soon as our stack is empty, we'll return true, that is yes, my parentheses are valid and the given question is correct. Like we have a valid parenthesis case and we can solve it using a stack data structure very easily, right? So now let's see how we can write the code for this particular question on Leetcode and solve, right? So let me just try moving upon to Leetcode. Now let's see how the code for valid parenthesis looks like, right? So we have seen the explanation. First thing that we do is we create a stack. Let's say stack of characters. Let me name it as sta, and let's calculate the size of this string. Now we'll run a for loop. For int I is equal to 0, I less than n, I plus plus. If the value of s of I is equal to the opening bracket, first is single opening bracket, right? Or s of I is equal to curly bracket, right? or s of I is equal to this open bracket, right? So after that we'll do sta dot push. Inside this we'll push this open bracket, right? This is the if part. Now we'll go on to the else part, and first thing that we do here is we'll check for the stack. If stack size is 0, so what we'll do, we'll simply return false, right? Next thing is we'll check for character of the, like, we'll check for the top of the stack, that is sta dot top. We'll remove the topmost element, that is sta dot pop, right? If now we'll check for all the cases, different cases for opening round bracket, opening curly bracket, opening square bracket, right? So for each of the cases we'll try to write the condition. This, or we'll check for this, if this is equal to bracket and character is equal to this opening bracket, or third case, s of I is equal to this closing bracket and character equal to this opening bracket, right? I hope this is correct. Yes, this is correct. Now what we'll do, we'll continue if everything is matching, else we'll return false, right? So this is basically the code that we have written for this. I guess it should be correct. As soon as we come out of the for loop, what we see, we'll see if the stack is empty or not. If the stack is empty, we'll simply return true. That is, we can simply return sta dot empty. So yeah, this would be the case. Let's see if we can run this particular case. So there is a bracket missing. I think it should be fine now. Yeah, so we're finally able to solve this problem. Now let's see how the code was written. Basically, let's go through the code once again. We have created a stack sta. We have taken the size of the string, that is s dot size. We ran a for loop. We checked for the opening brackets. As soon as we found an opening bracket, we pushed that into the stack. In the else case, after we check if the size of stack is 0, we simply return false. Then we took the first element, that is the topmost element of the stack. We popped that element and we put a condition if the stack top is matching with the pair that is we are getting in the string. So we will continue further. Else, if there is a mismatch, we'll return, and at the end what we'll return, if the stack is empty, we'll return that it is true. Else we'll return that it is false. So this was all for this particular question. Let's move on to the next problem. Hi everyone, we are going to discuss the next problem for the series. The next problem is basically trapping rainwater. So what we are given in this particular question is we are given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining, right? So we are given an input array of non-negative integers, and each of these integers represents the elevation of the buildings, right? So we need to calculate the total amount of water that can be entrapped in these buildings, right? So the width of each of these bar is given as 1. So as you can see, they have given an example with the heights 0 1 0 2 1 0 1 3 2 1 2 1. So basically for this particular case, the output is coming out to be 6. The above elevation map is represented by an array of this. In this case, 6 units of rainwater are being trapped. So we'll discuss the approach for this particular problem, and then we'll come on to submit this problem here and see how it goes, right? So let's see the problem that we're going to discuss. It's called by the name of a rainwater trapping problem. So let's just see the case. We are given a situation of this sort, right? So we are given buildings. Let me just copy down the same example of heights 1, 0, 2, this is 0, then it is 1, again it's 0, it's again 1, then it's 3, let's say it's 3, then it's 2, let's just see if it is 3, then it's 2, then after 2 it is 1, then again 2, and then again it is 1, right? So this is a problem that we are given, and we need to calculate the amount of water that can be entrapped. So what I mean to say by the water entrapped is, so let's say if water can be entrapped here, so water will, if rain is falling, water will be trapped here, right? There are chances that water will be trapped here also, right? And there are chances that the water will be trapped here also. So total amount of water that can be trapped is, like, the width of this is 1, so height is also 1, so this, from here we get 1, from here what we get, this part is basically 1, this is 2 units of water, this is 1 unit of water. So total water here is 4 and 1 unit of water here, so total water comes equal to 6 units of water. So this is basically what we need to calculate in this particular problem, right? So what can be the easiest and the brute force approach that comes to our mind when we see this problem is basically based upon this fact that we will be calculating the left maximum, and we'll be calculating the right maximum for each of these indices, right? And correspondingly what we'll do, we'll find out the minimum of left maximum and right maximum, and we'll subtract the height of this particular building. Let's say, for example, on this, at this particular index, right, this is 0, 1, 2, this is the second index. At second index, what is the left maximum height? The left maximum height is 1, right? The right maximum height that we have at this particular position is the right maximum height is 3, right? So we'll find out the minimum of both of them, and we'll subtract the height. Subtract the height of second index. So minimum of 1 and 3 is 1, minus height of 2 is, it's 0. So 1 unit of water will be stored here. Similarly, we'll go on to this position. What we'll see, this is third, this is fourth index, right? So we'll find out the minimum, left maximum. The left maximum at this particular position is 2, and the right maximum at this particular position is 3. So out of 2 and 3, we'll choose the minimum, and we'll subtract the height at fourth index. So minimum out of 2 and 3 is 2, height at fourth is 1, so we can store 1 unit of water here. So generalizing this, what I can say is, it will be minimum of left maximum and right maximum minus the height at that position. So this probably gives us the solution to the total number of buildings. Like, we'll be doing this thing for each and every index, each and every building. right? So what would be the time complexity in this case? So time complexity in this case is going to be O of n square, because we'll be going at each and every location, we'll be calculating left maximum, right maximum, and then we'll be finding out the minimum. So and we'll be traversing over the array as well, right? So it takes the time complexity of O of n square. Space complexity in this case will be going to be O of 1. We need to optimize this particular approach, so let's see how we can optimize this approach. So for optimizing this approach, let's just see how that can be done. Let me just draw this building chart once again, right? So again we have let's say 0 1 0 2 1 0 1 3 2 1 2 1. So this is the chart that we are given. So we have 1 here, we have 2 here, we have 1 here, we have 1 here, we have 3 here, we have 2 here, we have 1 here, again we have 2 here, we have 1 here, right? This is the building chart, right? So what we can do is we can optimize this approach a little better by using prefix and suffix sum. So we'll calculate a prefix sum, we'll calculate a suffix sum. So prefix sum and suffix sum means that we will be calculating an array, will be storing each and everything in this prefix array. So what can we store in this prefix array? So we'll store the maximum heights from the left. So now at 0th position, what is the prefix? Maximum prefix is 0 at this first position. Now prefix 1 is greater than 0, so we'll update it by 1. Again at 0, the left maximum is 1. Again 2, now 2 is greater than 1, so we'll update it by 2. Here also the left maximum is 2. Here also the left maximum is 2. Here also the left maximum is 2. Now it comes 3. 3 is greater than 2, so we'll update it by 3. For here, this is again going to be 3, 3, 3, and 3. So this is going to be the prefix array. And suffix array for this particular case would be, we'll start from the end. So in this case it will be 1, right? 1 is greater than 0. For now it's 2, 2 is greater than 1. Again it will be 2, 2 is greater than 1, 2. Again it will be 3 on from here onwards, right? So all will be 3. So this is going to be the prefix sum array, and this is going to be the suffix sum array. So now this makes our process little easier, because in this particular condition, right, minimum of maximum of left and maximum of right minus height of array. So we don't need to calculate maximum left, maximum right each and every time. We can pick up the numbers from here, from this suffix array and from this prefix array, right? So this will help us optimize our approach in a better way. So the time complexity in this case, like for calculating prefix sum array is O of n, for suffix sum array is O of n, for calculating this function it's O of n. So we can say that it's going to come as O of 3 of n, or you can say it's close to O of n. Space complexity, if I talk about, now you have to create these two. So space complexity is going to be 2n, or you can say that O of n. So now the space complexity is creating a problem here. We want to even optimize the space complexity. How we can do that, right? So there's a better approach. There is a better approach of 2 pointers. Let's discuss that approach and see how we can further improve upon this approach that can help us solve in better space complexity, right? So what we are going to do in this particular approach is, let me just draw the building chart once again, right? So here I have 0 1 0 2 1 0 1 3 2 1 2 1, right? So this is a building of height 1, this is a building of height 2, this is a building of height 1, this is a building of height 1, this is a building of height 3, this is a building of height 2, again it's building of height 1, building of height 2 again, and building of height 1 again. So this is the building chart. Pardon me for my bad handwriting, but I hope you'll be able to understand well, right? So let me just, this is the sizes, these are the sizes. Let me just put the indexes also: 0 1 2 3 4 5 6 7 8 9 10 11. right? So what we're going to do in this particular case is we'll take the left pointer that will initialize as 0, we'll take the right pointer that will initialize as n-1, where n is the size of this array, right? So what we are going to calculate, we are going to calculate left maximum, we are going to calculate right maximum. So initially we'll mark both of them as zeros, and we'll have a result variable, and this result variable will basically store the height, the amount of water stored, right? So this will basically store the amount of water stored. So what we are actually going to do is, initially the value of L is 0, R is n-1, so L stands here, that is left is here, right is here, right? You can say L and this is R. So what we are going to do is, we'll firstly we'll compare if at all this array of L is less than equal to array of right. So we're going to compare both of them. So here it is 0, it is 1, so it is obviously less, so we'll move inside this if statement. Inside this if statement, what we are going to do is, we are going to mark these things, the value of left max, right max. We'll see how these values are going to change inside this if condition. So we'll write this condition: if the value of left is greater than equal to left max. So we'll see if it is greater than or equal to left max. Left max is initially 0, this is also 0, so yes, if it is greater than, but it is not greater than, but it is equal to left max. So we'll put the value of left max is equal to a of L, and we'll go to the else case. But here it is 0, so we don't need to update. We'll simply go on and do L++, right? So we increase the value of L here. Now again we'll compare this L and R. So if ARR of L is less than ARR of R, yes, we are this is true, ARR of L is less than ARR of R. So we'll go inside the loop, we'll check if A of L is greater than equal to left max. Now left max is 0, so it is obviously greater than left max. So what we are going to do, we'll update this left max equal to A of L. Updating this left max equal to A of L will give left max equal to 1, right? And we'll do L++ again without doing anything as of now. Like we haven't written this else condition till now. Now we'll move this L again. Again I'll check if L is greater than ARR of L is greater than ARR of right. So you can see that ARR of left here is again less than equal to ARR of right. We move inside, we'll check if array of L is greater than equal to left max. Now left max is 1, but array of L is 0, so we don't need to update that. We'll go to the else condition. So what we are going to do in this else condition is, now we have created this variable result. Initially it is 0, so this result variable is going to calculate the value at this particular position, right? So this left variable is going to calculate my left max minus the height at this particular position. Like initially we had something like this, right? Minimum of left max and right max minus height at that position. Now here what I need to do is, if this statement is not valid, so we are at this particular location, we know that 1 unit of height will be stored here. So the result value will be result plus equal to left max minus ARR of L, right? So in this case result will be updated to 1, right? Now we move on to the next L++. So we are here. Now we'll check if ARR of L is less than equal to ARR of right. No, this is false, so we'll not go inside this loop. We'll create an else block. So else block is something like this. So if this condition is false, we'll move on to the else block. Inside this else block, we'll again do the same thing, but from the right perspective. We'll do array of right if it is greater than equal to right max. Now initially the right max value is 0 and value of A of R is 1. So if it is there, so we'll do right max equal to a of r, and we'll do something else, and after this we'll do r minus minus. So else statement, again it is going to be the same. We'll do result plus equals to write max minus arr of r. So this is going to be the case in this. Now we'll do, like, we'll see what happens in this case. So here arr of 3 is less than equal to now arr of r. So we'll not go inside, is greater than now arr of r. So we'll not go inside this loop, we'll go inside the else loop. So going inside the else loop, we'll see that arr of r is greater than equal to write max. Yes, it is true. We'll update the write max as 1. Right now, updating write max is 1 and doing r minus minus. We'll do r minus minus, write will come here. Right, we'll again compare arr of l and arr of r. Now you can see that arr of l is less than equal to arr of r. This is true. We'll go inside this, we'll check if array of left is greater than equal to left max. Now left max is 1, arr of l is 2, so we'll update this value and we'll do l plus plus. Doing l plus plus brings me here. So again I'll check if arr of l is less than equal to arr of r. Yes, this is true. We'll go inside this, we'll check if array of left is greater than equal to left max. So this is false. So we'll go in the else block where I'll put the value of result plus equals to left max minus arr of I. Now left max is 2, 2 minus arr of 1. So it will be 2 minus 1 in this case, and 1 will be added in the result. So it will become now 2, and we'll again do l plus plus. Right, so doing l plus plus brings me here. Now again I'll compare this arr of l is less than equal to arr of r. I'll check if array of left is greater than equal to left max. No, array of this is not true. So what I'll do, I'll go move on to the else part. In the else part, what we are doing is result plus equals to left max minus arr of I. So now left max here is again 2. So it will be 2 minus arr of I. The value of arr of I is 0. So 2 minus 0 is 2. So we'll add 2 here and it will become 4. So now the value in the result is 4. Again we'll move forward, we'll check l of 6. Like, we'll do l plus plus and we'll move on here. So moving on here, we'll give the value of arr of l as 1. So I'll compare it with the right portion. Now it is again less. I'll go inside this if block. This is not true because like 1 is less than equal to 2. Right, so we'll move on to the else part. In the result part, we'll add result plus equal to left max minus arr of I. So now arr of l here is 1 in this case. So we'll do 2 minus 1. It comes out to be 1. So we'll add 1 here. So it becomes 5 here. Again we'll do l plus plus. Now we are here. Now the value of arr of l isn't less than equal to arr of r. We'll move on to the else part. Here we'll check if arr of r is greater than equal to write max. Yes, arr of r is 3 now. Write max is 1. So I'll update this as 3, right? And I'll do r minus minus. Now it will move from here to here. R minus minus, we are here at this particular location. So now I'll again check arr of r and arr of l. Again arr of l is greater than arr of r. Then what we are going to do, we are going to move in the else block. Moving inside the else block, what we see that arr of r is greater than equal to write max. No, this is not true because arr of max is 3, but arr of r is 1 here. So what we are going to do, we are going to the result part, result plus equals to write max minus arr of r. So it will be write max is 3 minus 1. So 3 minus write max is 2. 2 minus 1, it's coming out to be 1. So we'll add it in the result part and we get the value of result as 6. So again we'll do r minus minus. Doing r minus minus, we are here. So again we'll perform the same step, and as soon as this l becomes greater than r, will stop. So this is going to be the starting condition. So I hope you have understood the approach. If you haven't understood the approach, make sure you watch it again and try to dry run it yourself. We have discussed 3 approaches for this particular problem. The first and the brute force approach is basically we'll be calculating the left maximum, we'll be calculating the right maximum, we'll be finding the minimum out of both of them, and we'll subtract the height. This will give us the solution, but the complexity will be O of n square, so we'll not go by this. Secondly, how we have tried to optimize it is by using prefix sum and suffix sum. When we are using prefix sum and suffix sum, everything is all right. We are able to get the left maximum and the right maximum, but we are creating the extra space. So we want to reduce this extra space, we want to reduce this O of n. So we are moving on to the third approach, that is a 2-pointer approach. So in this 2-pointer approach, what we are doing, we are taking left pointer as 0, right pointer as n-1. We are calculating the value of left max, right max, and result. So we are creating 2 particular conditions. If ARR of L is less than ARR of R, or else condition, and we are correspondingly doing the same thing, right? Here what we were doing, like this was the initial thing which we were getting off by O of n square. Now we have splitted the both of these part. We are doing right max minus height of I in else part, and we are doing left max minus height of I in the if part. So basically this gives us a time complexity of O of n and a space complexity of O of 1. We don't need to create any extra space, and this comes out to be my most optimal solution for this particular problem. I hope this is clear. If it is not clear yet, make sure you watch this video again and try to dry run this approach on paper. We'll see the code, you will be able to understand it better through the code now, right? Let me move on to the code part. So this is rated as a hard problem on Leetcode, so make sure, don't worry if you haven't understood it in one go. Make sure you watch this video again and try solving it on your own. So what are the things that we did in this particular question? We created, first of all, we let's just have the value of n, that is equal to the size of this height vector. We are given a vector of int, right? Now int left is equal to 0. These are the pointers that we have initialized. Int right is equal to n-1. We also create int result, that is equal to 0. Then int max left equals to 0. Int max right equals to 0. Right, these are the things that we have initialized already, and we are going to do this until and unless this left is equal to less than or equal to right. This was the condition that we checked, right? What we are going to do inside this while loop, so inside this while loop we'll be making the same conditions, the type of code we have written there and type of code I'm writing here. So firstly, it's an if block in which I'm checking if the height of left is less than or equal to height of right. So what we were doing in this particular case is we were checking if again, if the height of left is greater than or equal to left max or max left. So if this was the case, what we were doing, we were simply updating our max left to height of left. What we are doing in the else part, we were adding in the result plus equals to max left minus height of left. This we are doing here, and after moving from this if else, like apart from this, what we were doing left plus plus, right? So if this condition is not true, then we are moving inside this else block. So what we are doing in this else block is, so we'll check if the height of right is greater than equals to maximum of right. So we'll update this max right equal to height of right, and in the else part, what we did was result plus equals to, again it's max right minus height of right. This is something that we were doing. I hope this will be okay, and we need to do right minus minus, and as soon as we are out of this loop, then we will be returning this result variable as our answer. Return result. So what we did in this particular case is we firstly calculated the size of this input vector. We calculated the left variable, left 0, right of n minus 1. We calculated the result, initialize the result as 0, left maximum as 0, right maximum as 0. We ran this loop until left was less than or equal to right. If height of left is less than or equal to height of right, for this particular case, what we did was we checked out for different conditions. So the first condition is basically if height of left is greater than or equal to left max, we'll simply update the left max, else we'll add the value of the resultant. How we are calculating the resultant? Left max minus the height of that particular building, and we are doing left plus plus. Similarly, if we'll go in the else block, we'll check for the right case. If height of right is greater than or equal to maximum of right, then maximum right will be updated by height of right, and when we'll go inside the else block, we'll add the value in the result, that is result plus equal to maximum of right minus height of right, and we'll do right minus minus, and we'll simply return this result. Now we'll try to see and run this code if it is working all right. So yes, for this particular question we are getting the correct output for this particular input. Let me try to submit if it is getting submitted. Yes, we are successfully able to submit this particular problem. So that was it for this particular problem. Let's move upon to the next problem. Now let's see what is the next question. So the next question that we're going to discuss is basically we're going to search in our rotated sorted array. So what you're given in this case is you're given an integer array nums which is sorted in ascending order with distinct values. Prior to being passed on to your function, nums is possibly rotated at an unknown pivot index. Right, so we have a rotated sorted array. Given this array, after a possible rotation, we need to return the index of the target value. So basically we need to search an element in this rotated sorted array. So you can see they have given an example of 4 5 6 7 0 1 2. So this array, as you can see, it's not sorted, right, if you see it at the first position, but if you see, like, we start from 0, then it comes out to be 0 1 2, then 4 5 6 7. Now it seems to be sorted. So it is sorted and rotated array, and they have given the target as 0. So we need to give the index of this 0th position, right? So the index of this 0th position is, like, here it is 4, so we'll output 4. Similarly, if there is no such element, let's say 3, so there's no 3, so we'll return -1 in the output in that case. So we will be trying to complete this particular function of search where we have been given a vector int of nums and a target, and we'll be trying to solve this problem and seeing its approach. Right, so what we are given is, let's take the example of the same example that they have given, that is 4 5 6 7 0 1 and 2. Let's say we have this particular array. Right, so for this particular array, I need to find out what is the target. Target is 0, so I need to calculate the value of the index of 0. So the first approach, or the noob approach that we have in our mind, is basically that of linear search. So what happens in linear search is we go over to each and every index of this array and we'll see if it is equal to 0. If it is equal to 0, we'll simply return that particular index and we get the answer. So for this particular approach, the time complexity is going to be O of n, and the space complexity for this case is O of 1. But is there anything in which we can improve this particular approach? Like, whenever there is a sorted array given, right? So the first thing that comes to our mind is basically binary search, on how we can use or we can apply binary search in such a problem. But applying binary search in this particular question might be a little tricky. So we'll see how we can apply binary search and improve this complexity of O of n while applying this binary search, right? So let me just go on and right. So this is something that we know, that binary search, and binary search, what we need to do is we need to we have a left pointer, we have a right pointer, and we find out a mid, right? So generally we compare this mid with our target, if it is equal to our target, or if it is less than our target, if it is greater than our target. So accordingly we move on to the left part of the array, neglecting the right part, move on to the right part of the array, neglecting the left part, and so on. But in this case, what we are going to do is, let's say we have this initially we have left and right pointers, and we calculate the mid. So mid is coming out to be here. So what we'll do is we'll compare this and this. We'll see if this part of the array is sorted or not, right? So how we can check if this part of the array is sorted or not? We'll compare if ARR of left is less than or equal to ARR of mid. If this happens, or if this is true, then we can say that left part is sorted. And if left part is sorted, we'll try to see if target lies in the left part. How we can see if target lies in the left part? We'll check if target is greater than or equal to ARR of left, and if target is less than or equal to ARR of mid. So if this is the case, what we'll do, we'll simply move our right pointer to mid -1, and we'll neglect this part. What we'll do, right is equal to mid -1, and we'll neglect this entire part. Else, if we'll see this condition is not true, matlab my target is not lying in between left and mid, so that means my target is lying in the right part. So what I'll do in that thing is I'll do left is equal to mid +1. So in the else condition, we'll have left is equal to mid +1, right? So this is something that we are looking forward to do in this particular question. Like if this is the case, right? If this is not the case, if the left part is not sorted, what we'll do, we'll check on in the right part, we'll go on the else condition, and inside the else condition, we'll see if the target that we have, whether it is greater than or equal to array of mid, or it's less than or equal to array of right. If it lies in this particular portion, if it lies in this particular portion, then what we are going to do, we are again going to move our left is equal to mid +1. So left will come here. We'll try applying binary search in this part. Else we'll try apply binary search in the right part. Right is equal to mid -1. After this, we'll simply after this part is done, what we'll do, we'll simply try to see, we'll return -1 if all the cases fail. That means the number doesn't exist, right? So let me just try to dry run this thing on this particular example so that it's of a better clarity to you. So we have this same thing, 4 5 6 7 0 1 and 2, right? So for this particular question, I have left here, I have right here, and I calculate my mid, and my mid comes out to be here. My target that they have given is 0. Let me mark the indexes also, right? So I have something of this particular sort. So what I'm going to see in this particular question is, so firstly I'll compare the array of left is, whether the array of left is less than equal to array of mid. Yes, it is true. So we so that means our left part is sorted. So we'll check if target lies in the left part. Now is it true that 4 is less than equal to 0 or 0 is less than equal to 7? So no, this is not the case. This is false statement. So we'll move on to the else part, and moving on to the else part, what we'll do, we will check if this part, we'll compare the value of target with this part, right? If it lies between 0 or if it lies between 2. So yes, it is equal to 0, we'll simply move left is equal to mid plus 1. So if left is equal to mid plus 1, so that means my binary search will be applied here again. So now we have left here and right here. 4 and 6 will calculate the mid. It comes out to be here. So we'll again compare left and mid. So we see that 0 lies in this particular portion. So we'll again apply binary search here. So now left is this and mid is this. Applying binary search here, right comes out to be here. So now left and right both are at this particular position, that is position 4. So mid comes out to be 4. As soon as mid comes out at position 4, we'll simply return the mid. That means whenever the array of mid becomes equal to my target, I'll return the middle index. This is something that I'm going to do, and we are done. So middle index is 4, so answer in this case is going to be 4. Now let's see how this works in code. You will be able to understand it better by visualizing the code, right? So you can see here in the code part, let's try to write. We are given a vector of integer by the name of nums. So the first thing that we do in binary searches, we'll calculate the left index, that is 0. We calculate the right, that is equal to nums of size minus 1, right? We'll run this while loop. While left, will do the binary search only and only if left is less than equal to right. We'll go inside this loop. We'll calculate the mid. How we calculate the mid? We can calculate in 2 to 3 ways. I hope you know this particular thing, how we calculate the mid. So left plus right, right shift 1, right? So now we'll put the condition. We'll check if the first thing is if nums of middle, right? If nums of middle equals to target, will simply return middle. That's the very first case. Like we directly got the answer at the middle, right? If this is not the case, what we are going to do, if nums of left is less than or equal to nums of middle, right? So that means my left part is sorted. If left part is sorted, I'll check whether my target is greater than or equal to nums of left and my target is less than or equal to nums of mid. So if this is the case, I'll move my right to mid minus 1, else I'm going to put my left is equal to mid plus 1, right? So this is going to be the if condition. If this is not the case, if left part is not sorted, I'll go on to the else part. I'll check if my target is greater than equal to nums of mid. If it is the case and my target is less than or equal to nums of right. So what I'm going to do in this case is I'm going to do left is equal to mid plus 1, right? So I'll move on to the right part of the array. Else right is equal to mid minus 1, sorry, and we are done. I hope this should be clear, right? So we'll come out of this while loop and we'll return -1 if nothing of the cases happen. That means the particular number is not present in my array anymore. So I hope this is clear. Let me just try to run this code and then we'll try run the code once again. So for this particular input, I'm getting 4 as the index, that is 0 is present at the 4th index. Let me try to submit this code and see if it is getting submitted. Yes, we have successfully submitted this problem. Let's just go through the code once again for a better understanding. So you can see that inside our search function, I've created left and right, that is the left index of the array, right index of the array. I'm using a while loop to compare the left and the right pointer. If we'll continue our search only and only if left is less than equal to right. Firstly, we calculate the mid. We'll compare if nums of mid is equal to target. If it is true, then we'll simply return the mid. If nums of left is less than equal to nums of mid, that means the left hand side of the array is sorted. If this is the case, then we'll compare our target with nums of left and nums of right, nums of mid. That means I'll check if my target lies between the left, between the sorted part of the array. If that is true, so I'll simply move my right is equal to mid minus 1, else I'll move on to the right part of the array, neglecting the left part. If this is not the case, that means my left part is not sorted. I'll have to go to the right part. If I'll go to the right part, I'll check if my target is greater than equal to mid. That means I'll check if my target is lying in the right part. If it is lying in the right part, I'll simply do left is equal to mid plus 1, else I'll do right is equal to mid minus 1. And this is the case if all the cases in this while loop, after passing through all the conditions in this while loop, if nothing of the sort happens, I'll simply return minus 1. That suggests that the number is not present in my array. Right, I hope this is clear. We have been able to successfully submit this problem. It was a medium level problem on Leetcode. Now let's move on to another problem. So the next question that we're going to do in the series is sliding window maximum. So in this particular question, what we are given is we are given an array of integers nums, and there is a sliding window of size k, right? We are given a size of sliding window as k, which is moving from the very left of the array to the very right. You can see only the k numbers in the window. Each time the sliding window moves right by one position, find the maximum sliding window. So what they're trying to say is, let's say they have given this particular example. In this particular example, what we can see is we are given an array. So we are given an array, let's say 1, 3, minus 1, minus 3, 5, 3, 6, and 7. So in this particular array, the window size is given as 3. So out of these three numbers, 1, 3, and minus 1, the maximum is 3. So we give the output as 3 corresponding to this. Then for the next window, again, the maximum is 3. So we give 3 as the answer. For the next window, we have 5 as the maximum element, so we give 5 as the answer. For the next window, we have again 5 as the answer, we give 5 as the in the output array. For the next, we have 6 as the output index, we give 6 as the output. For the next, we have 7 as the output, we give 7. So this is basically what we are trying to do in this particular problem. Now let's discuss the approach for this particular problem and see how we can code, right? So let me just take the same example. We are given an array of the sort 1, 3, minus 1, minus 3, 5, 3, 6, and 7, right? So this is the problem that we are given, and we have to find a sliding window maximum. Right, the value of k that they have given in this question is 3. That is, we need to calculate in the size of 3, in the array of size 3. So for this particular thing, like for this particular value of k equal to 3, so what we'll check is what we can do is, the first and the naive approach that we have in mind is we'll go over to all the indexes, all the sub arrays of size k. Like for the first sub array, we'll find out which is the maximum, we'll put 3 as the output. Then we'll do it for the same, we'll do it for this particular array, we'll do it for this particular sub array, for this particular sub array, and so on. We'll keep on doing it for all the sub arrays that are present in my given array, right? For this, I need to write a for loop that is running from 0 to, like, the last index that will go on is till 5th, so I is equal to 0 to 5. Then inside this, I'll move one more loop that will run from this to this. Now that is for 0 to k, and I'll do some operations, and it is going to be of this particular sort. So for this, let's calculate the time complexity. It will be O of n into k, because I'm running a loop over all the elements 0 to n, and for every n I am calculating 0 to k. So the complexity will be O of n into k, which is not very good. We need to optimize this particular complexity and see how we can solve this question in a better way, with a better approach, right? So we are going to use a data structure known as DQ for this particular question. DQ is basically, it's a form of a queue. Like in queue, what happens is we can push from the back and we can take it out from the front. But what happens in a DQ is both ways the operations are possible. We can push from the front, we can pop from the front, we can push from the back, we can pop from the back. So all 4 operations are possible. It is implemented using doubly linked list. right? So now we'll see how we'll be solving this particular problem using the concepts of DQ, right? So when I've said that, let's take that example and see how we can run that particular case on this example. It is 1 3 minus 1 minus 3 5 3 6 and 7. So this is the example, right? The value of k is 3. So we'll create a DQ first of all. This is the DQ, let's say, right? In this DQ, like initially the DQ is empty. Also we need to maintain a decreasing sequence, right? We need to maintain a decreasing sequence. I'll tell you more about it once we get to the answer, once we get to the approach. Also I'll maintain an output array or an output vector that will store my answer, right? So this output vector that is going to store my answer. So in this DQ, I'll check firstly it is empty. I'll also mark the indexes of this array, right? So marking the indexes of this array, I'll go and see, let's say for the first particular index, 0th index, I have 1 as the corresponding output. So as my DQ is empty, I don't have anything to do. I'll put the index of this first element and I'll mark 1 as here. Now this is done. I'll move on to the next index. As soon as I move to the index 1, I'll compare this, the number that is present at the index 1, that is 3, with my with the number that is present in the with the number that is present at the index 0. So as soon as I compare 1 and 3, I know that 3 is greater than 1. So if in a window of 3, I know there is one element which is greater than the second element, so there's no use of this particular element, right? So we can remove this from my DQ and also from here, and I'll put 3 here and I'll add 1 in my DQ, right? As soon as I move on and I'll go on from 1 to the second index, I'll check for -1. Again I'll compare 3 and -1. Now in this case, 1 -1 is less than 3, that is it is following a decreasing order, right? So I'll write -1 here and I'll add the index of -1 to my DQ. Now we have covered this particular DQ, like one DQ is covered. So what at the end of this, what I'm going to do is I'll look at the front of my DQ and see what is the element present at the corresponding index. So the index is 1, so the corresponding element is 3. I'll put 3 in my output and I'll move forward. As soon as I'll move forward, I'll go on to this particular case, right? So now I'll compare the element present at 2 and 3. Again, it is following a decreasing order. I'll write -3 here and I'll add the corresponding 3 into my index, right? Now as soon as I move in the next window, or as soon as I move to 5, I come out of this window and I see that there's no use of this, because now I don't have this 1 coming in my window of 3, right? So there's no use of this. This is going out to be out of bounds. So I'll remove this number and I'll simply compare -3 and 5. Now if I compare -3 and 5, 5 is greater than -3. So as we have done, so they are not maintaining a decreasing order. I can remove this -3. This 3 was removed. So I'll remove this 3 and third index also from the queue. Similarly, I'll compare this 5 with -1. Again, -1 is lesser, -1 is lesser than 5. They're not following a decreasing order. I'll remove this 2 from the DQ, and also I'll remove this from the decreasing sequence, and I'll add 5 here and 4 here, right? But before that, like for the previous case, we forgot to mention the output that we used to calculate by checking the front element. The front was 1 in that case, so the answer comes out to be 3. So for this particular case, now we have again completed one more sub array. So for this particular sub array, we'll check the front of the DQ. It is coming out to be 4. We'll mark 4 as the output and we'll move forward. Now as soon as we move to the next sub array, we'll check if 3 is lesser than 5. Yes, 3 is lesser than 5. I'll add 3 here, I'll add 5 here, the index here, and correspondingly I'll check the front of this DQ. It is again coming out to be 4. I'll put 4 here. Sorry, the value corresponding to 4, that is 5. So here also 5, here also 5. So the 5 I'll get as my output. Similarly, we'll go on and solve till all the array elements, like until and unless they are finished. We'll do this and we'll go on doing this. We'll get 3 3 5 5, and after that we'll get 5 again, then 6, then 7, and our problem is solved, right? So for this particular case, the time complexity that comes out to be it's O of n, and again the space complexity comes out to be O of k. Why k? Because we are maintaining a dq of size k. So this is the particular problem that we have discussed. Now let's move on to the code part and see if we can code this particular solution so that we can understand it in a better way. I hope you have understood. If you have not understood, try to dry run it on your own. You will have a better clarity on the concepts, right? So if we'll move on to the code part of this particular problem, let's say we are moving on to the code part. First thing is we'll be creating a dq of int. Will create a vector of int answer that will store my answers. Now I'll run a for loop for int I equals to 0, I less than nums of size, I plus plus, and we'll check for each and everything inside this. If my dq is not empty and dq dot front is equal to I minus k, that means it is my dq is going out of bounds. So what does this mean is we can do dq dot pop front. We'll remove the front element from the beginning of the array. So what I mean to say by doing this is basically I'll check, right? I'll check for how should I explain? Yeah, so I'll check for basically if, let's say I have this particular thing, right? So why I have done this thing in the code, that is dq dot front is equal to I minus k. I was checking this condition, right? So if my I is here, let's say k is here, like there are 3 elements that is beforehand, that is my dq. So this element, that is I minus kth element, is coming out of bounds. So this is the condition for out of bounds that I'm checking, right? So that's why I've written that thing. Now we'll remove that front element, that is basically we have checked if it is out of bounds or not. Now again I'll go on to a while loop. While dq is empty, I'll compare the last element of my dq whether it is lesser than or not to maintain the decreasing sequence that we have discussed, right? So what I'll be doing is I'll check if nums of dq dot back, the last element of the dqs, right, is lesser than nums of I. If this is the case, then I'll do dq dot pop back until and unless I get a bigger element or decreasing sequences maintained. So after this is done, what I'm supposed to do is I'm supposed to check if if I'll be pushing in my dq, like I can push back the answer in like the index that I'm pushing back is greater, right? We are starting it again, that is we are getting the decreasing sequence, right? Again, like the last thing that is left is I'll check for and I'll put that thing in my answer if it at all is valid. If I is greater than or equal to k minus 1, so what I'll do in answer, I'll push back nums of for that particular dq we are pushing the front element in the answers, that is dq dot front, right? And after this is done, probably we'll try to return my answer and see if it is working fine. Yeah, so this is what we were trying to see, and let's try to submit this problem, and then we'll try to run the code once again. So what I'm doing in this particular problem is, so we have successfully submitted the problem. So what I'm doing in this particular problem is I'm creating a DQ, right? I'm creating a vector of answer that will store my final answer. I'm running a loop for int I is equal to 0 till int is less than the size of this vector. What I'm going to do is, first, this condition is basically it's checking whether my DQ is out of bounds or not, right? So I've explained you why this I minus k comes. Now, while if this particular condition is used to check if the decreasing sequence is maintained, right? Else I'll do dq dot pop back. If both of these things are done, then the thing that I'm going to do is I'll push back the ith position in the DQ, like that is only and only if it is maintaining a decreasing sequence. At the end, if everything is all right, I'll move the front element of the DQ if the value of I is greater than or equal to k minus 1. That is, we have covered the window of 3, right? And finally we'll return the answer, and I hope this is clear. Now let's move on to the next problem and see how we can solve that. So if you're watching this video till now and you're liking the content, make sure you hit that like button and subscribe this channel. Hi everyone, so now we are going to see some problems related to trees. We'll talk about pre-order traversal in a tree, we'll talk about in-order traversal in a tree, we'll talk about post-order traversal in a tree. And when I say tree, particularly I'm talking about a binary tree. So we'll see basically how using recursion we can solve these particular problems, these tree traversals, and what do they actually mean, right? So moving on to the discussion. Yeah. So the first thing when I say tree traversal is, right? So let's say we have a binary tree. You all know what is a binary tree. Binary tree is a tree that have two children, like exactly two children, right? Let's say we have something of this sort: 1, 3, 4, 5, 6, 7, right? Let's say this is the binary tree that we have, and we want to perform a pre-order. So pre-order is something that has, like, you need to know this. Like, first we'll print the root, then we'll go for the left node, and then we'll go for the right node. So this is the order that is followed in a pre-order traversal. So when I say pre-order traversal, the first thing that, like, this is the root, right? This is the root node that you will get, that, like, you have the access to this root node, and using this root node you should be able to print the traversal, right? So when I say pre-order, so how the traversal actually looks like. So the first thing is this is passed on to us as an argument. So we'll print this, like, first thing that we print is the root. So answer will be 1. Now after this, I'll go to the left tree. So I am going to this particular tree. So when I go to this particular tree, now this whole subtree is my new problem. Now this root will be passed. So the first thing that I'll be printing here is 2. Right, after 2 I'll go to 2's left, right? So when I go to 2's left, I go to 4, and now this whole subtree will be my new tree. This 4 doesn't have a left or the right subtree, so it is basically null or null. So whenever there is a null, so we'll simply return back, right? And we'll print this 4, right? Once this 4 is printed, like, for this particular tree, the left part we have covered. Now as soon as we have covered the left part, we'll go to its right. So we'll check for 5 if it has left or right. It doesn't have left or right, we'll simply return, and we'll print this 5, right? So now this 5 will also return. This whole thing we have covered, and we'll return back. So 1 we have already printed. We have printed its left side. Now we're going to its right side. When I say right side, I'll go on to this. Now this whole subtree is my another problem. When I say this whole subtree is my another problem, so basically this 3 will be treated as another root node. So I'll print this 3, then I'll go to the left part of the 3, that is 6. 6 will be printed. There is no left or right child of 6, hence we'll return back. From here also we'll return back. After 3 we have printed 6. After 6 we can print. We'll go back, this will return. After this we'll go to its right, so 7 is there, and Again, for left and right child of 7, there is nothing. So we'll return back from 7. Once we are here, we'll return back again. We have covered this entire thing and we are going back, and finally our question is solved. So this is basically what looks like a pre-order traversal, right? This is a pre-order traversal. So basically, firstly, let's discuss about what these traversals are and what they actually mean. Then only we'll move on to the code part. So now you very well understand what is a pre-order traversal. Let's just have a look at what an in-order looks like, right? So when I say in-order traversal, so in-order traversal looks something like 1, 2, 3, 4, 5, 6, 7. Like, let's say this is the tree and I want to print its in order traversal. So when I say in order traversal, so here the order is left subtree, left, root, and then right. Right, so this is the order that will follow in order traversal. So again, we'll have this root as one of the arguments. If we have this root as one of the arguments, so this will be passed. So I'll get this root. I'll first go on to its left subtree. When I say I'll go on to its left subtree, I'll go on to this particular tree. Again, this node will be passed on as its root. So when this node will be passed on as its root, so for this root also we'll again go to its left subtree and we'll see if there is any left. So there's no left. We'll check for right and left. So because there's no left or right for 4, both of them are null. So we'll simply return from here. Right now left is null, so we don't print anything. We'll print the root. Root is 4 in this case. 4 is the first number that we'll print here, and then we'll go to the right. Right, so there is no right of 4 also. So again we'll return back, and finally we return back from this. Now for this particular subtree, we have covered its left portion. Now the thing that we need to cover is the root. So after 4 we are going to print 2, right? So after this is done, now we'll print the right portion of the of this particular subtree. So for 5, again I'll check for right or I'll check for left. Again both of them are null, so I'll not do anything. I'll simply print 5 and I'll return back. Now this entire left tree is covered. Now as soon as this entire left tree is covered, we'll return back. As soon as we return back, I'll move on to this one. So left part is covered. Now I am on the root. I'll print 1 and I'll go to the right part. When I say I'll go to the right part, this is again a new subtree, it's again a new problem. So now 3 will be passed on as a root. So when 3 will be passed on as a root, again we'll go to the left part of 3. So going to the left part of 3, I'll go to 6. I'll check for the left of 6 or the right of 6. Both of them are null. So I'll simply return from this side also, return from this side also. And like left portion is null, so I'll go on to the root. I'll print 6. I'll check for the right. Again it returns back null, so I'll not do anything. I'll simply return back. Now left portion is completed for this subtree. I'll print 3 now. After 3, now I'll go to the right subtree. I'll check for left of 7 or right of 7. Left also gives us null, so we'll print we'll not print anything from the left side. We'll simply print 7. Then we'll go to the right. Again it's null. We'll simply return back. Once this is done, we'll return back, and finally this is done. So this is the in order traversal of this particular tree, right? So I think you people are getting this. What is an in order, what is a pre-order? Now let's discuss about post order also as of now, so that you can have a better clarity, and then we'll combinedly discuss all their codes and we'll try to code it on IDE as well, on Leetcode as well, right? So third thing is post order traversal. So when I say post order traversal, so for post order traversal, basically you need to have this particular format: left, right, and root. When I say left, right, and root, let's say again I'll take this example: 1, 2, 3, 4, 5, 6, and 7, right? So now this is passed as root. Now we'll start from this. First thing is we'll cover the left part. So I'll move on to this particular part of the tree. So once this is passed, so 2 will be passed on to as a root. So for this particular tree, I'll go on to its left portion. When I'll go on to its left portion, I'll check for its left or I'll check for its right. So both left is null, right is also null. I'll simply print the root and I'll return. Right. So the next thing is after this 4 is done, so we'll return back here. Now rather than printing this 2, I'll go on to its right. I'll check for left of 5, right of 5, both of them are null. I'll simply print 5 and I'll return back. Now left is also done, right is also done. Now I'll print the root is 2 in this case. So this is like this entire left portion is covered. Now once we are done with this, we'll return this back. Right, once we return this back, we are at this 1. So now this 1 will not print, we'll go on to its right first, because we have covered this left portion completely. Now we'll cover this right portion. When I say right portion, for this particular right portion, 3 will be passed as root. So when 3 is being passed as root, so we'll go on to the left of 3. When I say left of 3, so it is 6, right? So for 6, we'll check for the left and the right subtree. Both of them are null. So we'll simply will not print anything for this null also. And we'll print this root, that is 6. Next, I'll go back to 3. Will I print 3? No, I'll not print 3. Firstly, I've printed left. Now I'll print right. Right of 3 is 7. Right, I'll check for left and right of 7. There's nothing null, so I'll not print anything. I'll print 7 and left is also done, right is also done. Now I'll print this 3. Once this 3 is done, this entire right part of the tree is done. Earlier we covered left part, now I have covered right part. Now I'll again return from this. Now both left is done, right is done. What is left? Root. So I'll print this root here. Right, so this basically gives me the post order traversals. So there are multiple ways in which we can print these as a part of our code. Basically, people prefer using recursive methods, right? There can be iterative methods by using stacks or using 2 stacks in some problems. So those can also be discussed, but let's just stick on to the recursive approach as of now for these particular questions, right? So let me just take you through the code, how the code will dry run for these particular questions, and then we'll go on and code for these particular questions, right? So let me just if we discuss, let's say, pre-order, then all other traversals will be very clear to you, right? Let me just discuss this pre-order. So when I say this pre-order, right, let me just draw that tree. 1, 2, 3, 5, 6 and 7. So this is the tree, and I want to print the pre-order of this tree. Pre-order traversal of this tree. Right, so let's say you have something of this kind. Void pre-order is the function name, and inside this function, what you are passing on the root. You have something like node star root. You are getting this root from the main function, and you need to operate on this root. What does this root specify? This root points to the first root of this particular tree, right? So when I say code part, so what happens, I told you we will be doing the recursive version. So in a recursive code, there are 3 things, right? The first thing is base case. The second thing is recursive call. And the third thing is small work that we do, right? These are the 3 things that we do in any recursive problem. So we'll be covering a base case, we'll be having a recursive call, and that's it, right? So basically, when I say this particular question, so pre-order is we have this particular functionality, right? Firstly, we'll print this root, then we'll print the left subtree, then we'll print the right subtree. So what should be the base case? Like, from where we were returning from when we were getting null at any point, right? So we're returning from here. So first thing is, we can check if our root is equal to null. If at all this happens, what we'll do, will not do anything, we'll simply return. I hope this is clear to all, right? So this part of the this part of the code covers my base case. Second thing after this is, The second thing that I'll do after this is I'll print this root. So the first thing that comes to me is I'll print this root. So let's say I am doing a cout. What I'll do the cout for root ka value, right? End. Let's say I've printed this root's value as my cout. Next thing is I'll call upon the left subtree, I'll call upon the right subtree, and my entire thing will be done. I'll call for pre-order of root ka left. This is my recursive call. I'll call for pre-order of roots right. And we are done. So this is basically pre-ordered reversal code. So let's just quickly go through and see if we can how we can understand it a little better. Let me just dry run and see how we will be getting to the same answer, right? So let me make a clean neat tree. So the tree is same tree we are taking. So again, this is the root that we have passed, right? So for this particular root, firstly I'll check if the root is equal to null, then we'll return. So here the root is not equal to null, will not return. We'll go on and print this cout root ka value. Root ka value is 1. I'll print 1 as my answer, right? I'll print 1 as my answer, right? After that, what I'll do, I'll go and call for print of root ka left. When I say root ka left, so this 2 will be passed as a root to my pre-order again. So now this entire subtree comes as a new call to this pre-order function. I'll check for 2 whether this root is null or not. This is not null, so what I'll do, I'll simply cout root ka value. Root ka value is 2 in this case. I'll go and call on roots left. So for 2's left, I'll go on and call 4. So 4 again goes, again it is not null, 4 ka value will be printed. So once 4 ka value is printed, we'll go and call for root ka left, that is 4 ka left. When I say 4's left, so it is going out to be null. So now I'll pass this null here, so it will return back. So we'll return back from here, right? After this, what we are going to do, like in pre-order, what happens is, first thing is we are printing the root, then we are printing the left, then we are printing the right? So now for this particular case, we have simply returned a null and we are done, right? So the next thing is I'll go back, so it comes back to 2. We have already printed 2. Now what happens is, now this call is completed. Now I'll complete this particular call, that is roots right. So this 2 calls for roots right, that is 5. So now this 5 is printed, 5 is sent to as an argument in this pre-order function. So again, I'll check for 5. I'll print the value of 5 and I'll check for its left and right. Again, they both are null, so I'll not do anything. I'll simply return back, and this 5 thing is also done, right? Once this entire thing is done, this left subtree is entirely done, I'll return this back to 1, right? So after that, now 1 has called for its root ka left, so this call is entirely done. Now I'll call for 1 ka right. So root ka right, that is 3, will be passed on to my function as an argument. So once 3 is passed on to my function as an argument, what I will do, I will again check for whether 3 is equal to null. No, 3 is not equal to null. I'll go and print out this root ka value. Root ka value is 3, right? So I'll print 3 and I'll go on and call 3 ka left. So 3 ka left is 6. So I'll go on and call pre-order root ka left, that is I'll pass on this 6. So when I'll pass on this 6, again I'll check if it is equal to null. No, it is not equal to null. We'll print the value of root. So we'll print 6 here, right? Once we print 6 here, for 6, now we'll call for left and right, both of them are null, so we'll simply return and will not do anything. So this 6 is done. Now this call is completed. We'll go on to this call, that is pre-order ka right. When I say pre-order ka right, 7 will be passed in my pre-order function. When 7 is passed in my pre-order function, then I'll check for whether 7 is equal to null. No, it is not equal to null. I'll print the value of 7. Once this 7 is printed, now my right call is also done, right? So I'll simply return after this, and like we have completed this function entirely. So this is something that we are expecting as an output. We can store this in vector, or we can store this as in array, and we'll be able to perform this particular function. So what is the difference between this pre-order, post-order, in-order traversals is what we are going to see now. Okay, I hope this much is clear to you. Let me just scroll it down a little bit. Okay, so I think we'll have to wrap this, and so that we will be able to compare them well also, right? So for the case of so this was for pre-order, where we know that what we have to do, firstly root is printed, then left subtree is printed, then a right subtree is printed. So this is for root. Now this is for pre-order. When I say in order, so the code for in order is also going to be very similar. Again, we'll be getting a root, node star root, and inside this what I'll pass if my roots is equal to null, again I'll return, right? And here just there is a transformation of the trees. So the first thing that happens in order is left subtree, then the root, and then the right subtree. So what change I'm going to make is I'll call on in order root ka left, right? I'll see out root ka data or root ka value, and again I'll call for in order roots right. So this function actually gives me the in order. So can you guess what will be the post order traversal? In post order, what was the basic criteria behind post order? Was it left root right or left? So basically for post order it was left, right, and then root. So for this to happen, what we'll do, we'll change the order again. So the order, everything else will be same. The order for post order will be something like this. It will be, first we'll call post order root ka left, then we'll call post order roots right, then we'll simply see out roots data. So this is what happens in a post order traversal. I hope these things are clear. Let's just move on to the code part and see how we can code these three traversals of tree. So the first question that we have in front of us is pre-order traversal. So what happens in pre-order traversal is, firstly we'll print the root, then we'll print the left subtree, then we'll print the right subtree, and it is an easy problem that is given in the Leetcode. All these three will be easy problems only, right? So because these are very important to understand different aspects of tree, how tree works, how tree functions. So make sure you are well aware of all these problems. So what they're expecting out of us is they're expecting out a vector int, right? So they're expecting that you should store the pre-order traversal in a vector of integers and you should return that vector. So for this to happen, let's say what we were doing in our code, we were pointing out the base case, right? So we need to make the changes inside this vector. Let me just create a vector of integer, let's say answer, right? And the last thing is, like, I'll make changes in this answer, I'll store my pre-order in this answer, and I'll return this answer. So this is the basic thing that we are going to do, and I want to make changes in this answer, right? So let me create a helper function. So when I say I'll create a helper function, so in this helper function, what I'll put the root and I'll put this answer, right? So let's create this helper function. Basically this is the helper function that we are going to in which we are going to store the pre-order traversal, right? So when I say helper function, so it is tree node star root and vector of int ampersand answer. So why this ampersand answer? Because we want to make the changes in this answer vector only. So when I say this answer vector, the first thing that we did was if this root is equal to null, what we were doing, we were simply returning, right? Else what we are doing, we are making three statements. What happens in a binary pre-order traversal? Pre-order traversal mein first thing we were storing in this vector was answer dot push back roots value, right? And next helper roots left will call, helper roots right will call, and I think we are done. Like there's nothing left for this particular question, right? So we have done this for pre-order traversal of a tree, right? So what we are doing is we are creating an answer vector in which will store the pre-order for this particular question. Then I am passing it on to a helper function that will return me the answer in a modified way, answer vector with all the answer, like the pre-order traversal of the binary tree, and will simply return this answer. Let me just try to run this code if it is working all right. Yes, we are getting the correct answer for this particular case, 1 2 3. We are getting 1 2 3 as our output. Let me just try and submit. Yeah, so we are able to successfully pass on this as our successfully. So let's just see if the same works for in order also. I'll quickly write on the code for in order so that we can save up on time. So when I say in order, again, what thing we are going to do, we are going to create a vector int answer. I'm going to create a helper function. Inside this helper function, what I'll put this root and I'll put this answer, and I'm going to return this answer. So this is what I'm going to do in this in order traversal. I'll create this helper function again. What happens in this helper function is I'm passing on the root, I'm passing on the vector int answer, right? So what happens, what I'm going to do inside this helper function is I'll firstly I'll write down the base case. If root is equal to null, I'll simply return. Else what I'm going to do for in order traversal, what used to happen, firstly we called upon the left subtree, then we called upon the right subtree, and then we firstly we called upon the left subtree, then we printed that root, and then we called upon the right subtree. Basically you should understand from this terminology in order, right? So in order means root is in between left and right. So that is something that can help us memorize things, right? So when I say helper, firstly I'll call a root ka left, then I will push back. What I'll push back? I'll push back root ka value, right? And after this, helper root ka right and answer. I hope this should be fine for in order traversal. Let's just try running this code and see what we get. Yes, we are getting the correct answer for this particular question as well. Let me just yeah, so we have successfully passed on this as well. Post order, let me just copy paste some of the things from this code and we'll just make the changes, right? So we'll again make all these three things for post order, right? So once these are done, so I'll again create a helper function. So inside this helper function, now what change we are going to make is this answer is something that we are going to change, and we are going to put this answer vector after both of these function calls, right? Now I'll run this code and see what happens. I think yes, we are getting the correct answer this way as well. So our submission is successfully accepted and we have successfully solved the three traversals in a tree: pre-order, post-order, and in-order traversal. There's one more traversal, that is level order traversal. I'll see if I can cover that in the later part of this video. So let's just move on to the next question. Hi everyone, so the next question that we are going to discuss is maximum depth of a binary tree. So basically we need to calculate the depth of the binary tree. Some people might also call it as the height of the binary tree. So when I say for this particular tree, how many number of levels it has? It has 1, 2 and 3 levels. So the answer for this particular question is going out to be 3, right? So let's just see how we'll solve this particular problem. It is also a very simple problem, right? So maximum depth of a binary tree, right? So let's say again we have this particular example, right? So for this particular tree, what should be the answer? It should be 1, 2, 3, 4. So the answer for this should be 4. Basically we need to return this 4. So how this thing actually works is basically we'll be solving this thing. The recurrence that will go forward for this particular question is, it will be 1 plus maximum of left subtree and right subtree. So what this is the root that will be passed to us, right? So what we'll check, we'll go on to its left part and we'll go on to its right part and we'll compare. We'll get the height of left part and right part and we'll see which is maximum. Let's say the height here for this part is only just only 1. For this part it is 1, 2, 3. So it is 3. So out of 1 and 3, which is maximum? 3 is maximum. So what we are going to return is 3 plus 1. So it is going to be 4. So this is something that we have in mind as of now. So let's just have a quick overview of the code for this particular function, how the entire code looks like, right? So it will be something like we need to return the depth of the tree, right? And we are being passed this tree node star root. So for this particular question, I'll check if my root is equal to null. So I'll return 0 in that case, because height will be 0, right? Else what I'll return? I'll return 1 plus maximum of depths of roots left or depth of roots right. So this is basic functionality of the code that we're going to write. If you want to dry run, you can dry run. What happens is 1 is passed on. We'll pass on 1 as the root. We'll check if it is null. No, it is not null. We'll go on and ask for 1 plus maximum of depth of root of left. So I'll pass on root of left in the tree. So root of left is basically this 2. I'll pass on as the answer. So for this 2, what I'll see, I'll go on and check if it is null. No, it is not null. For this 2, I'll do 1 plus maximum of this 2 ka left and 2 ka right. So 2 ka left and 2 ka right both are 0 because there is null. So what I'll return for this is 1 plus 0. So 1 plus 0 is basically 1 I'm returning from here, right? Similarly, if you'll go and dry run this, you will get the answer as 3. And once we'll compare 1 and 3, out of 1 and 3, the number which is maximum, we're going to add 1 in that and we are going to return. Let's just see the code, and I hope it would be a little more beneficial to you and you will be able to understand it better, right? So we are calculating the depth of the tree here. So when I say depth of the tree, what I'll look forward to first is the base case. If the root is equal to null, I'll return 0. Next is let's just calculate the left part. What will be the left? It will be max depth root ka left and right is equal to max depth root ka right, and I'll return 1 plus maximum of this left or right. So this is something that we are going to do in this particular question. Let me just run this and see if it is working all right. It is taking a little bit of time. Let me just refresh this page. Cool. Let's just try to run this code again. Yeah, so we're getting the correct output for this particular question. We are getting the answer as 3, expected as also 3. Let me just try and submit if it is getting submitted or not. Yes, we are successfully able to submit this problem, and I hope it is clear. Let's move on to the next problem. So the next problem that we are going to discuss is basically to, like, you're given the question in such a way that given the root of any binary tree, you need to return the length of the diameter of the tree, right? So what is the diameter? Diameter of a tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them, right? So let's say this is the tree that is given to us, and we need to find out the diameter of this particular tree. So when I say diameter, so the length of the longest path connecting two different nodes, it can pass through the root or it cannot pass through the root. Both of things are possible, right? So for this, you can see this 1, 2 and 3. So 3 is the longest path of the tree, so it can be through 4, 2, 1, 3 also. It can be 5, 2, 1, 3 also. Any of these paths we can choose, right? So similar approach that we are going to use. Let's just see how we'll be solving this particular problem, right? So what we are given is, we are given to find the diameter of this particular binary tree. So when I say diameter, right, let's suppose we are given a tree of this particular form: 1, 2, 3, 4 and 5. Let's say we're given one more tree of this particular form where it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say we are given these two trees and we need to find the diameter. So diameter, as I've already defined, they have mentioned up in the question, is it is the longest path between two nodes, right? The second property is the path does not need not pass through the root. Need not pass through the root. It may pass through the root or it may not pass through the root. Both of the ways are possible, right? So let's say for this particular tree, if we consider the longest path, so it will be something of this particular sort. It will be 1, 2 and 3. So answer will be 3 in this case. Maybe we can take this 4, 3, 1, 2 path, or we can take this 5, 3, 1, 2 path. So both of the paths will be giving me 3 as the diameter, so we can choose this. For this particular question, let's say if I'm passing through the root, I'm getting the answer as 1, 2, 3, 4 and 5. Let's say I'm getting the answer as 5, but there is one more path that might give me a better answer. It can be 1, 2, 3, 4, 5, 6. So this particular diameter that is connecting end to end, it's the longest path between two nodes, and it is not passing through the root, and it is giving me the answer as 6. So this can be the answer in this particular case, right? So we need to look forward to how we'll be solving this problem. Basic brute force that comes into mind is like how we solve all the problems related to trees, right? So we'll be going through recursion and all. So let's just see what approach we are going to follow and how we can improve upon that approach, right? So let's say we have this diameter function, and we are given this tree node is passed here, right? So for this, first thing is we'll check if the root is equal to null. If the root is equal to null, simply we'll return, right? Or you can say return 0. Then what we'll calculate the left height and we'll calculate the right height. So what happens is, if we calculate the left height and if we calculate the right height for this particular one, right, and if we add these left height and right height, we'll probably get the answer, right? So let's suppose if this is the case, right, 4, 5, 6, 7, 8, 9. If I get the left height and right height at this place, left height plus right height would be, left height is 1, right? We already know how to find the height, and right height in this case is 1 2 3 4, right? So this is going to be 4. So we'll be getting the answer as 4 from the right hand side, 1 from the left hand side. So 1 plus 4 gives me 5 here, right? So similarly, we need to calculate the left height plus right height for all the nodes and see what happens. For this particular 2, we'll be getting the left height as 0, right height as 0, so the answer is 0. For 3, I'm getting the left height as 1 2 3, for right height as 1 2 3, so I'm getting the answer as left height plus right height is 6 at this particular place. For this particular place, the left height and right height is, like, left height is 1 2 and right height is 0, so 2 plus 0, it's 2 again. For this particular position, it is left height is 0, right height is 2, so 2 plus 0 is again 2. For this particular case, the left height is 1, right height is 0, so the answer is going to be 1. For this particular case, the left height is 0, right height is 1, so answer is going to be 1. For this particular case, the answer is 0. For this particular case, the answer is 0. So what if I calculate the left height plus right height for all these nodes and I simply return the maximum out of them? Let's say for this it is 0, it is 5, it is 6, it is 2, it is 2, it is 1, it is 1, it is 0, it is 0. So out of all these, which is the maximum? It is 6. So maybe I can return 6 in this way, right? So this can be one approach. Let's see how we'll write the code for this particular approach. When I say the writing the code for this particular approach, so it can be something like you can say that diameter is something that you are calculating. You are getting this node root. So the first thing is you are checking if this is the base condition. If root is equal to null, then we'll simply return. We'll calculate the left height, we'll calculate the right height, right? For left height, it's height, sorry, we'll calculate the height. We know how to calculate the height for left and right specifically, and then we'll find the maximum of, like, let's say maximum h, maximum of max h and left height plus right height. So this variable will store what is the maximum out of all these. Then we'll again need to call this diameter function for roots left and roots right. So if you observe carefully, we are doing a lot of work here, right? So when I say a lot of work, we are calculating the left height and right height. So for this particular operation, as you have already seen in, we were using this something like this, 1 plus maximum of left height and right height, right? So for this, we need to go through the entire root. So it is giving me the complexity of O of n. So let's say if we have a skew tree, so for skew tree, all the nodes will be covered. So we'll be getting a complexity for this operation as O of n. Again, we are calling upon diameter of left root and right root again. So from here also, we will be getting a complexity of O of n again. So the overall complexity of this particular approach becomes equal to O of n square. So I need to improve upon this approach so that we can reduce the steps, or we can reduce the functions calling again and again. So how we can do that? Basically, you remember the code for finding the maximum height, right? So when I say remember the code for finding the maximum height, so it is something like we were doing int height, and we had this node, and we were checking if root is equal to null, then we were returning 0. Else we were calculating the left and right height. How we are calculating? We are calculating the height of roots left. We are calculating the height of roots right, and then we were finally returning 1 plus max of this left h and right h. So this is something that we were doing in our height function. So what if I say you need to just do a little more thing in this particular question so that we can solve this problem, right? We are getting the left height from here, we are getting the right height from here. What if I compare it here only? Let's say I'm having a variable diameter, and inside this diameter I am getting maximum of this diameter and left height plus right height, right? And I'm passing this diameter as one of the arguments here. Won't it solve the same purpose and we just need to traverse the entire tree once? So that is giving me a complexity of O of n. So basically this approach is going to be a little more better than the previous approach that we thought of, right? So let's, if you want, we can dry run this approach. Let's just have a little dry run over this approach, right? So when I say dry run, so I'm taking the example, let's say the same example I'm taking, it's 1 2 3 4 5 6 7 8 and 9. So this is the question, and we have written the code something like, let's say find diameter, right? And I'm passing node star root, and I'm passing diameter. So inside this function, first thing is if my root is equal to null, so I'll simply return 0, else I'll calculate left height, I'll calculate right height, and then I'll put in this diameter the maximum of diameter and left height plus right height, right? And I will return 1 plus maximum of left height and right height, right? So left height, how we'll calculate, we'll again choose this find diameter. I'll call roots left, find diameter, roots right, and I'll pass this diameter. So this is something that we can do. So let's just dry run. Let's say we have passed this 1, right? So 1 is coming as root. Initially the diameter is 0, so we are having diameter as 0. This is coming as this particular root node. So root is not equal to null. This is false. We'll go and find the left height. So for this particular root, the left height comes out to be 1, right? For this particular root, the right height comes out to be, you can go in depth also, you can go for this particular node also, and you can calculate the left height, right height again, but I'm just assuming it for like this, now it is coming out to be 1. We'll go for right height, find diameter again. So for right height comes out to be 1 2 3 and 4. So right height comes out to be 4, left height comes out to be 1. So in the diameter, initially it is 0. I'll find maximum of 0 and left height plus right height. So left height and right height is 5. So out of 0 and 5, the maximum is 5. So my diameter will have the value 5, and I'll return 1 plus maximum of left height and right height. So 1 plus maximum of left height and right height gives me 4 and 1 plus 1. So the answer that will be returned here is 5, right? So it is 1 plus maximum of left height and right height, maximum of 1 and 5, 1 and 4, right? So 4 is maximum out of both of them. 4 plus 1 5, so 5 is returned. Similarly, now what happens is, so I'll be getting the diameter in this case, right? Similarly, for all the cases, it is going to find out the diameter, and we will finally land up with the answer, right? So it is going to check for diameter again and again. Let's say for this is 5, for this it comes out to be, again it is coming out to be 3 from this case, 3 from this case, so it is 3 plus 3 6. So now this 6 will be replaced here, right? So this is something that we are going to see in this particular approach. Let's just see the code on how we'll be coding this particular part, and so that you can understand it a little more in a better way, right? So we are having int diameter. Let me just initialize the diameter equals to 0. So when I initialize diameter equal to 0 and I'm passing it in a helper function. So this helper function is basically going to give me I'm passing in the root and the diameter, and it will give me the answer. So I'll return this diameter once I get from the right. So let me just make this helper function. Int helper. So we'll be passing tree node star root, and we'll be passing int of diameter, right? So inside this, first thing is we'll check if my root is equal to null. If it is equal to null, I'll simply return 0, right? Else I'll calculate the left height, right height, so when I say left height, so what will be calculated? Helper of root ka left and diameter. Helper root ka right and diameter. ठीक है जी. After that, what I am going to calculate is I am storing in this diameter, like for example, for the first root that we pass, so it will have to traverse through each and every root, right? Let's say we have seen here, right? For example, 1 is passed. So for this particular one, we'll have to go through each and every node, each and every root to calculate the left height and right height. For example, for this one, so firstly, left height will find out the diameter of this particular 2. Now this 2 is passed on as a root. So for this 2, entire process will go and we'll get the value of, at 2 the value of diameter is 0. So we'll get the value as 0 and diameter में हम 0 डाल देंगे, right? For this particular 3, now this 3 also goes in this diameter, find diameter function, and it comes in this process, and we'll calculate the diameter for 3. So diameter for 3 comes out to be 6. So value of 6 will be updated in this diameter at one single point of time, and like 6 is the maximum. If we'll compare it with any other diameter, it will not affect that. So that's why we are it is just taking single traversal, and we are getting the value as O of n, right? So maximum of diameter and left height plus right height, right? So we have written this diameter, and what we return, 1 plus maximum of left height and right height. I think it should work fine if I'm not wrong. Right, so let's just try running this code. Yes, we are getting the output as 3, expected output is also 3. So let me just submit this problem. So we have successfully submitted this problem, and I hope it is clear to you now. Let's move on to another problem. So the next question that we're going to do in this particular series is level order traversal. So we have already seen what is pre-order, in-order and post-order traversal, and how we will be able to do them using recursion. Now we'll see level order traversal. It is very, very important traversal, and it has a lot of use cases, right? So let's see how level order traversal works. So let's say you are given a tree in such a form that it is 5, 4, 3, 2, 1, let's say 7 and 6. You are given a tree in such a way, and you need to print it level wise. So when I say level wise, what you need to think upon this is, like, it should be in such a way that first 5 will be printed, then after this second level will be printed, it is 4 and 3. Then after this third level will be printed, and so on. Then it will be 2, 1, 7 and 6. So how we'll do this? So for this we'll be using a queue data structure. right? So queue data structure will help us solve this particular problem. Now let's see how we'll utilize our queue data structure and we'll solve this problem, right? So let's just move up onto the queue part. So what happens is you create a queue, and inside this queue you insert one of the numbers, like that is the root, because initially once you're given a tree, so the first thing that you know about the tree is its root. So put that root in the queue itself. So 5 is here. So what happens next is how you will be storing the answer. So you'll be storing the answer in the form of vector int. So it will be in this particular format. So this means basically it's a big vector and inside there are a lot of other vectors, right? So each level will be stored in this particular vector and will be adding or pushing all these individual vectors into this bigger vector. So let's say we'll create a vector of int answer, and we'll take this 5 out and put it in our this one of these vectors. So let me say that this is the final bucket or the final data structure in which we'll be putting all the level order traversals, right? So I take 5 out, right? What happens is now I'll check for firstly I'll remove this from the queue. I'll check for 5's left and I'll check for 5's right. Do they exist or not? Yes. For 5 the left node is 4 and the right node is 3. So what I need to do next is I'll push on 4 and 3, that is the children of all the nodes that were present that we have removed. We'll put them in the queue and we'll put this 5 into our vector and insert it into vector of vectors. This is the first case, right? Now what happens next, as soon as this is done, so what I'll do, I'll again remove the rest, the objects or the elements that are available in the queue for the next case. So I'll remove 4 and 3. As soon as I remove 4 and 3, I'll check for the left of 4 and right of 4, left of 3 and right of 3. So left of 4 is 2, right of 4 is 1, left of 3 is 7, right of 3 is 6. So I'll add all these in my queue. So it will look something like 2, 1, 7 and 6, right? So these will be removed from the queue. Now I'll put them 4 and 3 in a vector and I'll insert them in my vector of vectors. So it will be something like 4 and 3, right? So this is the second case. Now again I'll remove all these elements from the queue. So all these will be removed and I'll check individually for the left and right if available. So for 2 there is no left and right, for 1 there is no left and right, for 7 there is no left and right, for 6 there is no left and right. So what we'll do, we'll not insert anything in the queue, and in that case my queue will stand empty. And we need to do this until and unless our queue is empty. So now in this case queue becomes empty. What we'll do, we'll put all these 4 in a vector and we'll insert in our vector of vectors. So it will look something like 2, 1, 7, 6, right? So this is basically the answer that I'm going to return, right? And this is how this particular code for level order traversal works. Now let's see how we can code it on Leetcode and try to submit it if there is any issue that comes up. So we'll see it accordingly, right? And then we'll try run the code as well. Now let's move up on to Leetcode. Yeah, so the question states that it's a medium level question on Leetcode. They want you to you are given the root of a binary tree, you have to return the level order traversal of its nodes values, right? What they want us to want in the output is they want a vector of vector int in the form of answer or result. So let me first make this vector of vector, that is this data structure, this bucket that will help us store our answer. So I'll initialize vector of vector int result, right? After that I'll check for root, like if at all this root is equal to null, then simply we'll return this empty vector, right? I'll not return anything, so it will be return of result, right? The next thing that I was doing was I was making a queue. So I'll make a queue of, let's say, a tree node type, tree node root, sorry, tree node, and I'll create a queue. So inside this queue I'll push my root. After this, until and unless my queue is empty, while my queue is not empty, what I will be doing is, the first thing that I'll do is I'll check for the size of the queue. Int size is equal to queue dot size. Like, what is the exact size of my queue at that particular point of time? Let's say we have added just one element, that is the root. So now the size of the queue will be 1. After removing root, we'll add its left and right, then the size of the queue will become 2. After removing 2 and 3, then the size of the queue will become 4. So every time we'll be checking for the size of the queue when we'll be writing our code, right? Next is, we'll create this bucket, that is vector of int, that will store my individual answer. Like, firstly, we are working only upon the root, so after 3 is removed, so 3 will be added into this answer vector. Then, like in this case, 9 and 20 will be added into this answer vector, and that answer vector will be put into my result vector, right? So this is that bucket that we have created. Now I'll run a loop for int I is equal to 0, I less than size, and I plus plus. What I'll be doing inside this is, I'll create for this tree node star node, I'll first take out the front element of the queue, then we'll do queue dot pop, we'll remove that element from the queue, right? And we'll check for if nodes left is not equal to null, then what we are going to do, we are going to put that element in the queue, right? So I'll do queue dot push nodes left. Similarly, we are going to do it for the right case. If nodes right is not equal to null, queue dot push nodes right. Right. After this, what we are going to do is, we are going to push back this entire thing in my answer vector. Like, I'll push back that front element that I've removed from the queue in my answer vector, that is answer dot pushback. What I'll be doing here is nodes value, right? So after this, the thing is, after this is done, then in result vector, we'll store this answer, result dot pushback answer. That is the individual thing, that is the vector that is going to be inserted in a vector of vectors. So at the end, we'll return this result, and I hope this should be clear. I think we have written the correct code. Let me just go through it once. Yeah, I hope it is correct. Let's try to run this code and see if it is correct. Yeah, so we are getting the correct output for this particular tree. Let's say 3, 9, 20 and 15, 7. We are getting the correct output. We are getting the output in the form of a vector of vectors, and it looks good. Let me just try and submit. So yeah, this is coming out to be correct. Now let's move on to another question. So another question is also a little similar. It is asking us to print that binary tree in zigzag level order. So what I mean to say by zigzag level order is, they have just changed that question in such a way that firstly you need to print 3, then instead of printing 9 and 20, you should go and print 20 and 9, then again 15 and 7. So it is going to be something like 3, 20 and 9, 15 and 7. Right? So they want us to print in this zigzag level order traversal. Now let's see how this zigzag level order traversal will be different from our already that we have done level order traversal, and how we can relate both of these questions, right? Let me just go through this part, right? So next question is, yeah. So zigzag level order traversal. So the question seems to be similar to what we have seen in the level order traversal, but there will be slight change, right? We need to keep a track on when to print from left to right and when to print from right to left. So that track will be maintained by a flag variable. That is what we are going to see in this particular approach, right? So this is the tree. Let's say we have 1, 2, 3, 4, 5, 6 and 7. Let's say this is the tree that we have. Now we want to print it in level order traversal zigzag format. So when I say zigzag format, firstly we'll print this 1, then we'll print this 3 and 2, then we'll print this 4, 5, 6 and 7. So the answer, it should be like, again it will be in the form of vector int. Like I'll be having this kind of vector int. So instead of level order traversal, what I'll be having, like 1 will be added here. After this, instead of adding 2 and 3, I need to add 3 and 2, right? So after this, again 1, 3 and 2, then 4, 5, 6 and 7. 4, 5, 6 and 7. So this should be the use case. This should be the answer that I need for this zigzag level order traversal, right? So again, for this particular question also, we'll need a queue. Let me just rub this for once. Right, so again I'll maintain a queue. Right, so inside this queue, first thing that I'm going to add is the root. I'll add 1 and that is the root. So as soon as 1 is added, I'll look forward to and I'll remove this 1. Right, and I'll look forward to the right and left of 1. Again we'll check for left and right of 1. Right, and like what is the difference in this particular question is I'll need to keep a track of whether I should enter the elements from left to right or I should enter the elements from right to left. For this, I'll be creating this flag variable. Initially the value of flag, let's say we are keeping it as true, and after every vector is being put into that vector, I'll flip this value of flag, or I'll change this value of flag from true to false and from false to true. So that means this flag value will tell us whether we should go from left to right, or we should go from right to left. So let's say if flag value is true, we'll go from left to right. If flag value is false, we'll go from right to left. Initially the flag value, let's say we have kept it as true because we are going from left to right. As soon as this traversal is done, as soon as we have put this 1 in my final answer, final vector of vectors, what I'll do is I'll change the value of flag to false, and as soon as flag is false, I know that now I need to enter the elements from right to left. So I'll do that in my code. Basically, let's say we have this, again we have this vector of vector. We have this vector of vector int, and inside of this vector of vector int, I've already added 1, so 1 will be added here. Next, I'll check for left and right. As soon as I'll check for left and right, I'll add 2 and 3 in my queue. Right, again I'll remove 2 and 3, and while adding 2 and 3, now I'll check what is the value of flag. So if the value of flag is false, which it will be, because once we have done it for true, next we'll reverse it for false. So if the value of flag is false, so that rather than entering 2 and 3, I'll enter 3 and 2. Right, so now 3 and 2 will be entered here. Again, for the next case, value of flag will change. Flag will be, if this statement suggests that if flag was true, then it will be turned to false. If flag was false, then it will be turned to true. So again, what I'll do, I'll add 4, 5, 6 and 7, and this is the answer that we expect. Again, like the process is similar. We'll calculate 2 and 3, we'll check for left of 2, right of 2, we'll check for left of 3, right of 3. If left of 2 exists, if right of 2 exists, if left of 3 exists, right of 3 exists, we'll add them into our vector like 4, 5, 6 and 7. So for all these, we'll check for, again, we'll remove all these and we'll check for left and right if available or not. So accordingly, we'll put them in our vector of vector int, and this is how we will be solving this zigzag level order traversal. More clarity will be there when you'll see the code for it, how we are changing this flag variable, how we are initializing this flag variable, and how we are finally able to solve that particular question, how we are finally able to submit the answer on Leetcode. Let's move on to the Leetcode question and see how we will be writing the code for this. So again, what we are given is, we are given a root of a binary tree. Again, it is a medium level question present on Leetcode, and you need to return the zigzag level order traversal of its nodes, right? The answer should be again in vector of vector int. So the first thing that I'll be doing here is, again, I'll create a vector of vector int that will store my final answers. Vector of vector int, let's say answer, right? If the value of root is equal to null, then what we are going to do, I'm simply going to return answer, that is the empty vector, because root is null, right? Then I'll create my queue again of the tree node type, let's say queue, and inside this queue what I'm going to do, I'm going to push this root. So I've pushed this root. Now I'll create this flag variable. Initially I'll mark it as true. So this flag is initially true. That means I need to go from left to right in the traversal, right? Again, similar step. I'll create a while loop for until and unless my queue is empty. As soon as for how long my queue is empty, then I'll create int size. So int size will tell me queue.size, the size of the queue, right? Then I'll create this vector of int, let's say result. So this will basically store vector of int, that is each level of the tree will be stored in this result, and finally these all results will be entered into that vector of vector int. So now I have done this. Again I'll run a loop for int I is equal to 0, I less than size, I plus plus, tree node star node is equal to q dot front, right? I've removed the front element. Q dot pop, I've taken out that front element and removed it from the queue, yes. And now I'll create this index variable, right? I've created this index. I'll check for the value of flag. So this is where the main part comes. If the flag is true, that means I'll have to go from left to right. If the flag is false, then I'll have to go from right to left. If flag is equal to true, then what I'll do is index value should start from I, else what I'll say, index value should start from the last element, that is size minus I minus 1, right? So this is the major step that we are going to do. This is the change that is reflected in this particular question, and one thing that we need to do is we need to change the value of flag after each traversal, right? So this is, if we have done this, I think so yeah, so result of this index, basically the vector in which we are storing, so that will store the index value either starting from I or starting from size minus I minus 1. If it is starting from size minus I minus 1, that means we are moving from right to left. If it is starting from I, that means we are moving from left to right. That totally depends upon the value of flag. So it will have nodes value, right? After this result is done, then again the same steps, we'll check for left and right. If nodes left is true, then we'll push nodes left into my queue, right? Similarly, if nodes right is true, then I'll push nodes right into my queue, right? So this is something that we'll do. After we have done this, now what we need to do is we need to check for, we need to reverse the value of flag. So initially if the flag value was true, so I need to make it to false. So I can use if flag is equal to true, make it equal to false, else make it is equal to true. Simply I can write this statement as flag is not equal to flag. So that means if flag is true, it will be turned to false. If flag is false, it will be turned to true automatically. And inside my answer vector, I'll push back this final vector that we have stored. So that is a pushback result, and finally I'll return this answer. I hope this should be clear. Let me just go through it once again. So vector factor and answer will be returning answer. We'll be creating a queue. We'll be pushing that root into the queue. We'll be creating a value of flag. Until unless this queue is empty, we'll check for size of the queue. We'll create a vector result. We'll run a for loop on that particular case. We'll remove the elements. I think it should be correct. We have changed the value. This is the major change that we have seen in this particular question. We'll create the value of index. We'll check it according to flag. If it is going from left to right, that means it is true. We'll maintain the value of index as I, else we'll maintain the value of index as size minus I minus 1. And for every case we are going to do flag is not equal to flag. That means if flag is true, we'll move it to false. If flag is false, we'll move it to true. So let me just run this code and see if it is all right. Okay, so there is a little bit of error. So we are finally able to see what the problem was in this code. Like we were running this code and like this is the error that is coming, right? So the error is in this particular line. So what this line doesn't mean anything. Flag is not equal to flag doesn't suggest anything. It should be flag equals to not of flag. That is, if flag is equal to true, we'll turn it into false. If it is false, we'll turn it into true. So after making this correction, we finally debugged this code and we were able to submit it successfully. And that was all for this particular question. Let's move on to another problem. So the next question that we're going to discuss is 1291 sequential digits. So 1291 sequential digits, basically what this question says, they are saying an integer has sequential digits if and only if each digit in the number is one more than the previous digit. Return a sorted list of all the integers in the range of low to high inclusive that have sequential digits. Let's say we are given low as 100 and high as 300. So in between 100 and 300, how many sequential digits are there? So what do you mean by sequential digits? Let's say 123. So in 123, we have after 1 comes 2, after 2 comes 3. Similarly, 234 is also a number which lies between 100 and 300 and it has sequential digits. Sequential digits ka matlab hai, it can be 1, 2, it can be 1, 2, 3, it can be 1, 2, 3, 4, 5, it can be 1, 2, 3, 4, 5, 6, or it can be 2, 3, 4, 2, 3, 5, 2, 3, 2, 3, 4, 5, 2, 3, 4, 5, 6. It's like it can start from any number, but the digits should be in sequence. Similarly, you can see they have given a second example in which the low is 1000 and high is 13,000. So you need to tell all the numbers that will lie between 1000 and 13,000 and they should be sequential in order, right? So let's discuss what can be the approach and what can be the probable solution for this particular question. So the question name is sequential digits, right? So what happens in the sequential digits is we are given a value of low. Let's say in the example it was given as 1000 and the value of high, let's say 13,000. So in between 1000 and 13,000, I need to list down all the sequential numbers. So from 1000 to 13,000, it can be, let's say, sequential digit means like it can be 1, 2, 3, 4. So after 1, 2 comes, after 2, 3 comes, after 3, 4 comes. It can be this, it can be 2, 3, 4 alone, it can be 2, 3, 4, 5. It can be 2, 3, 4, 5, 6, but 2, 3, 4, 5, 6 doesn't lie between this, so we'll neglect this, right? 234 also doesn't lie between this, so we'll neglect this. 2, 3, 4, 5 lies exactly between this and this, so we'll add this into our output. Similarly, it can be 3, 4, 5, it can be 3, 4, 5, 6, it can be 3, 4, 5, 6, 7. So now this is out of range, this is again behind the range, and this comes into the range, so we'll add these two. Similarly, it can be 1, 2, 3, 4 also, it can be it can be 1, 2, 3, 4, 5 also, because it is 12,300 hardware. So we'll add this also, we'll add this also, right? So we need to find all the numbers that lie between these the range, this low and high range, and how we'll be solving this particular problem. Let's try and discuss this approach, right? So for this particular question, what do you need to keep in mind is the first thing is, let's say we start from a number 0, right? So, and like the numbers can start from 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Numbers can start from 1 to 9, right? So it can be like from 1, if we need to start numbers, the numbers can be 1, 2, it can be 1, 2, 3, it can be 1, 2, 3, 4, it can be 1, 2, 3, 4, 5, it can be 1, 2, 3, 4, 5, 6, right? From 2, it can be 2, 3, it can be 2, 3, 4, it can be 2, 3, 4, 5, it can be 2, 3, 4, 5, 6, and so on. Similarly, from 3, it can be 3, 4, it can be 3, 4, 5, it can be 3, 4, 5, 6, it can be 3, 4, 5, 6, and 7, and so on. And we can calculate these things for all the numbers, right? So how we'll be doing it mathematically, or how we'll be calculating these numbers, and then after calculating these numbers, we'll check for if this lies between the range low and high, if it lies, then we'll add it into our resultant array, else we'll not add, right? So let me just show you the approach on how we'll calculate these sequential numbers. So basically, while calculating these sequential numbers, you need to keep certain things in mind, right? Let's say initially we take a variable num is equal to 0, right? And for every number, right? So initially, let's say num's value is 1 in this case. Initially num is 1. Then what we'll do, we'll multiply this num by 10 and we'll add the value of j. So j here, its initial value is, let's say 2. Right? You can start it from 0 as well. So let's say I'm starting it from 1. I'm just giving you an example on how this works actually, right? So num value is 1, I value is 2. So and we are using this formula num into 10 plus j. So when I say num into 10 plus j, 1 into 10 plus j is, the value of j is 2, right? Initially the value of j is 2, so it comes out to be 12. In the next case, the value of j increases to 3, right? Now again num into 10 plus j. Now the value of num is 12, right? This will be storing it in num only. Num is equal to num star 10 plus j. So 12 into 10 plus 3. So it comes out to be 123. Similarly, we'll go on and the value of j increases to 4. Num now becomes 123. So 123 into 10 plus j. J is 4 in this case. So it becomes 1, 2, 3, 4. Similarly, we can calculate, and once we calculate 12, we match it whether it lies in this range or not. If it lies in this range, then we'll add it into the array, or like we'll make a resultant vector. Let's say we make a resultant vector and we'll keep on adding the numbers which lie in this range into our resultant vector. So in this case 1, 2, 3, 4 lies in this case, so we'll add 1, 2, 3, 4 in the resultant vector. Similarly, for 1, 2, 3, 4 into 10 plus 5, it gives us 1, 2, 3, 4, 5. This also lies in the range, so we'll add. Similarly, we'll do this for 2 as well. So when we'll do it for 2, so it will be, the value of num initially would be 2, right? So 2 into 10 plus the value of j will be initially 3. 2 into 10 plus 3, it gives me 23. Again, if I go forward, it will be 23 into 10 plus j value increases from 3 to 4. It becomes 4. So it gives me 234. Similarly, 234 into 10 plus the value of j increases from 4 to 5. It becomes 2, 3, 4, 5 and so on. So we can do this for entire, like now we have calculated 23, 23 doesn't lie in the range, will not do anything. 234 doesn't lie in the range, will not do anything. 2, 3, 4, 5 lies in the range, so we'll add 2, 3, 4, 5 into our resultant factor, and after every number is done, right, we'll go on from for 1 also, for 2 also, for 3 also, for 4 also, for 5 also, for 6 also, for 7 also, and let's say for 7 we are doing 78. First number will be 78, then it will be 789. Then it will be 789. After 789, is there anything left? No, no. So we'll not do anything. We'll stop here. So this is basically the approach that we are going to follow for this particular question. I believe when we'll write the code, it will be a little more clear to you. So let's move on to the code and see what the question has to say for this particular approach, right? So let's say we are writing, the first thing that I told you was to make a resultant vector. Let's make a resultant vector of integers. Let's say we name it as result only, right? Then we initialize the value of int num is equal to 0. Then we run a for loop for int I is equal to 1 to I less than 10, I plus plus. Now this we'll be initializing our num to I, right? Like initially the value of num is for 1. For all, like for the value of 1, we'll check for all the cases, all the sequential numbers, and whichsoever lies in the sequence of low and high, we'll add that, right? So I'll put num is equal to I. Now again we'll run a loop. We'll check for all I plus 1 to 10 if there is any number that can be a sequential number, right? So it comes out to be j is equal to I plus 1 and j is again less than 10, j plus plus, right? So I'll do num is equal to num star 10 plus j. This was the thing that I was doing. I was calculating the value of num by num multiplying by 10 and adding j in that. So after I have calculated the value of num, what I will do is I'll check for the upper and lower bounds, right? If it is if the value of num is greater than or equal to low, and also the value of num is less than or equal to high, right? Then what I'll do, I'll add or I'll push back in the result vector. So it will be result dot pushback num, right? And at the end, what they have told us to return a sorted list of all the integers. So as we have to return a sorted list, so we'll need to sort this result vector because it might not be the sorted case that we are looking forward to, right? So after this, what we'll do, we'll use an inbuilt sort function. How we'll do an inbuilt sort function? It will be result dot begin to result dot end, right, and return result. So this is something that we are going to see in this sequential digits question. Time complexity for this will be O of n log n because we are sorting the array, right? And we are not using any extra space, so it will be space complexity won't be a problem. So let me just try and submit if we can submit this particular problem. So yes, we have successfully submitted and this question has been accepted. For 100 to 300, the output is coming out to be 1, 2, 3, 2, 3, 4. Expected output is also 1, 2, 3 and 2, 3, 4. So this was all for this particular question. Let's let's move on to another problem. So the next question that we are going to see is, it's a very interesting problem. Basically, the name of this problem is Coco eating bananas. So let's first read out the problem and then try to understand what this problem is saying and how we can solve it, right? And it's one of the very famous problems that is being asked in Amazon from time and again. So the question says that Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles of I bananas. The guards have gone and will come back in h hours, right? So there are bananas lying in piles. There are n piles, and in each pile there are piles of I bananas. So Coco can decide her bananas per hour eating speed of k. So the number of bananas that Coco can eat per hour is her eating speed, that is k. Each hour she chooses some pile of banana and eats k bananas from that pile. Matlab she chooses a pile, usme se she eats k bananas, right? That is her per hour speed. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. If at any time in that pile the bananas are less than k, so she'll eat all the bananas and she'll eat no other banana in that hour, right? Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. So we'll have to find the minimum speed that Coco should have so that she can eat all the bananas within h hours, right? This is something that we need to discuss. Let's just have a look at the question. The input that they have given is, there are piles, like in the first pile there are 3 bananas, second pile there are 6 bananas, third pile there are 7 bananas, and fourth pile there are 11 bananas. And the value of h is 8. That is the number of hours that the guards will take to come back is 8, right? So let's have a closer look at this problem. So let me just increase the space and then we'll start, right? So what happens in this question is, the question name is Coco eating bananas, right? So we were given a case that was 3, 6, 7 and 11. So that means these are the piles. In first pile there are 3 bananas, in second pile there are 6 bananas, in third pile there are 7 bananas, and in fourth pile there are 11 bananas. And Coco, and the value of h they have given is 8. That means 8 are the number of hours in which the guards will come, or she'll have to eat the bananas at a minimum speed k. So k is her speed, like she will be eating k bananas per hour. We need to calculate this value of k, and this should be the minimum value because she likes to eat slowly. Matlab she doesn't like to eat fast. So we'll have to consider it accordingly, right? So let's take a let's take a guess, right? Let's say Coco eats 3 bananas per hour. So 3 bananas in an hour means like she will be taking 1 hour to eat 3 bananas. If there is in any pile there are less than 3 bananas left, she'll eat all the bananas and she'll not eat any other banana in that particular hour. Let's try to see how many hours she will take to eat if she's eating at the speed of 3 bananas per hour, right? So for the first case, like for the first pile, 3 bananas are there. She'll eat all 3 bananas in the first hour, and it will take 1 hour for her. For the next pile, there are 6 bananas. So from these 6 bananas, she'll eat 3 bananas, and 3 bananas will be left, and the hours will increase to 2. Right? So in the third hour, she has 3 bananas left in the second pile. She'll eat these 3 bananas, and the number of hours will increase by 1. In the next hour, she will eat 3 bananas from this pile, and she'll have 4 bananas left. Again, the number of hours will increase by 1. For the next hour, again she'll eat 3 bananas, and 1 banana will be left in the third pile. She'll again increase the number of hours to 5. Again, now 1 banana is left in this pile. She'll have to eat this 1 banana, and she can't eat any other banana in this hour. So we'll increase the hours by 1, and this becomes like this pile is finished, because in this hour she will be eating only 1 banana, because she can't move on to another pile in this hour, right? After that, 11. So 11 minus 3 is basically 8. So 8 bananas will be left, and 1 hour will be increased more. Again, 5 bananas will be left, and 1 hour will be increased more. Again, 2 bananas will be left, and 1 hour will be increased more. Again, 1 hour will more be needed, and she will be completing these in 10 hours. So what we have understood from this is, like, if Coco is eating at a speed of 3 bananas per hour, so she will need at least 10 hours to complete eating the bananas, till all the bananas are finished. But we are given that she has only 8 hours. So if she's eating 3 bananas per hour, so she's taking more time, right? So if she's taking more time, this is what can we do? We need to increase the speed per hour, right? Increasing the speed per hour might help us to reduce the number of hours, right? So we know this. So now earlier we were having 3 bananas per hour. Let's say we are having, like, we take another example for 4 bananas per hour. So when I say 4 bananas per hour, and the given value is 3, 6, 7 and 11. So for 3, 6, 7 and 11, let's say 4 bananas are to be eaten in 1 hour. Let's calculate the time that she'll be taking in eating at this particular speed. So when I say at this particular speed, so for 3, so when so for the first hour, she'll be eating all these 3 bananas. For the next hour, she'll eat 4 bananas from this pile, and 2 bananas will be left. She'll take 2 hours. Again, these 2 bananas will be eaten in another hour. She'll take 3 hours. For this, again, 4 bananas will be eaten in the first hour. 3 bananas will be left. She'll increase the number of hours to 4. Again, for this, it will be eaten in another hour, that is 5. For this 11, it will be eaten up in 7, like 7 bananas will be left, and will increase the number of hours. Again, for this, the number of hours will, the number of bananas left is 3, and the number of hours we can increase it to 7. For this, the number of, like, 3 bananas are left, she can eat it in another hour, and she takes 8 hours exactly. So if she's eating at this speed, that is, after 3, what is coming? 4 bananas per hour. So now she is taking 8 hours to eat all bananas at a speed of 4 bananas per hour. Right? So this is the speed that she currently has. Let us take another example so that we can understand the intuition behind this problem. When I say intuition behind this problem, let's take a very, very hypothetical number. Let's say she eats 7 bananas per hour. So we have 3, 6, 7, 11 again. So if she's eating 7 bananas per hour, let's say in the first hour, she'll be able to complete this. It's over. In the second hour, she'll be able to complete this. It's over. In the third hour, she'll be able to complete this. It's over. In the fourth hour, she'll be able to complete this with 4 bananas left. In the fifth hour, she'll be able to cover these 4 also. So in this case, she takes only 5 hours, right? So in this case, she's taking only 5 hours to eat all the bananas. But what we can see from this is 5 is significantly less than 8 hours, and she has increased her speed to 7 bananas per hour. But we need a minimum speed. minimum optimal speed, right? We can't take this also, we can't take this also, because it is taking more time, it is taking less time. The optimal speed, which is minimum, is 4 bananas per hour, right? So what we can understand from this particular approach is, we are like, this is something that brings us to the approach of binary search. When I say binary search, like, we have certain conditions, we have made certain conditions that if this particular x is less than a value high, or if this value is greater than a value high, so we have certain conditions for that, right? So this brings us to our approach of binary search. What happens in binary search is, we we have a start, we have an end, and we calculate the mid. According to a certain given condition, we either move to the left side or we move to the right side. So similar is the approach that we are going to use to solve this particular problem. Let's say we are taking, initially there can be 1 banana per hour to the maximum of, let's say, 11 bananas per hour, or we can take a very high number in binary search. Let's say we are taking the int max, that is, if the range is given as 10 raised to power 9, so we'll take 10 raised to power 9 as a right pointer, right? So if 1 and 11 are given, let's say we calculate the mid. If we are calculating the mid in this case, just a minute. Right, so if we are calculating the mid in this case, so 11 plus 1 by 2, let's say mid is coming out to be 6. So if mid is 6, then mid will be somewhere here. So that means if the value of k, this mid denotes the value of k. Let's say if 6 is the number of bananas Coco is able to eat per hour, then how much time will take? So again, the example was 3, 6, 7 and 11. So if she's eating 6 bananas per hour, so what is the exact number of hours she's going to take? So for 3, she'll eat in first hour. For this, she'll eat in another hour. It will take 2 hours. For this, she'll eat in another hour, but 1 banana will be left, that will be done in next hour. For this, it will be done in another hour, it will take 5. For this, it will be done in another hour. So she will take exactly 6 hours to finish if she's at the speed of 6 bananas per hour, right? So what we can conclude from this is that her speed is significantly high, because the maximum hours that we have is 8 hours, right? So what we need to do in this case is, we'll compare this 6, right, with 8, and we'll see how many number of hours she's able to take to eat these k bananas. So she's taking 6 hours. So 6 is lesser than k. So what does that suggest? She's able to finish it earlier. So we need to reduce the speed. That is, we need to move to this part of our array, and this part will be completely neglected. When I say this part of the array, so what happens is, when we move to this part of our array, so left will be the same and my right will become mid minus 1. So right will be mid minus 1, that is, my right will be 5. Now I'll again apply binary search for this case. So by applying binary search for this case gives me 5 plus 1 divided by 2, that is 6 divided by 2 is 3. So now I have 3 as the midpoint. Again, we'll check for 3. How many number of hours will she take if she's eating 3 bananas per hour? If she's eating 3 bananas per hour, so the number of hours she will be taking in this case is, like, we have already calculated for 3 bananas, she was taking 10 hours. Now 10 hours is greater than this 8 hours, right? So she need to increase her speed. If she needs to increase her speed, then we'll move to this part of the binary search or this array, and this part will be neglected. Now if to move to this part of this array, now left will become mid plus 1. If my left becomes mid plus 1, that means my left becomes 4. Left is 4, right is 5. 4 plus 5 by 2 gives me 4. So I'll check for 4. So for 4 also we have calculated earlier, it comes out to be 8 hours, right? So as soon as it comes out to be 8 hours, so that means we are at the minimum number that is possible. So hence we'll return with this speed, that is 4 bananas per hour is the answer that she will be able to eat those bananas. Right, I hope this approach is clear. Let's just move on to the code part and see if we are able to write the code for this particular question, and if there are any doubts, we'll dry run the approach for more clarity. Right, so this is the particular question that we have, and we are given the function signature of the form that we need to return an integer value, that is we need to return the value of k. Along with that, what we are given is we are given a vector int piles. That means it has the number of bananas in each pile and the value of h, that is the number of hours those guards will take to come back. So this is what is given to us in the question, and the first thing that we did in this particular approach is we were applying binary search. Let's say int left starts from 1 and int right starts from the maximum value, that is let's say 10 raised to power 9. You can take this value as a little different also. Okay, so we have written this. Now we'll apply binary search. For applying binary search, what we'll do, we'll compare until left is less than or equal to right. We'll calculate mid. Int mid is equal to left plus right minus left divided by 2. Why we are finding mid in this way? Because else the condition will overflow. We'll discuss it later in some other question if this is not clear to you, right? If it is not clear, you can let me know in the comment section. I'll provide you the solution for this as well, because the value of mid might overflow if we are just doing left plus right by 2, right? So after this, we need to apply binary search. For this, we'll create a helper function that will help us helper in time, whether she'll be able to eat those bananas in that specific time that we will be getting from this particular function. So in this function, what we'll pass on this piles array or piles vector. Along with that, we'll pass on the value of mid, right? Mid is basically the value of k that we want to see, and along with that h, that was the initial value. So if this value comes out to be true, then what we are going to do, then we are going to reduce our bracket of k. That means we are going to reduce the speed. So if we are going to reduce the speed, that means what exactly will it come? My number of hours will come out to be less, right? If we are able to solve it in time, then my number of hours are less than 8, less than or equal to the number of total hours. So I'll make right is equal to mid minus 1, right? Else part, what will happen is, for else part, I will see if this doesn't happen, if it is not able to pass in the required time, that means it is taking even more time. So we need to increase the speed. For increasing the speed, what we'll do is we'll move to the right part of the array. Moving to the right part of the array means I'll increase the value of left to mid plus 1, right? So if else statement is done, and after doing this, we'll simply return the left part, or the number which is coming out to be the left, right? So this is basically minimum meeting speed that we have made. Now the next thing is how to write this helper in time function, right? So writing helper in time function is basically we'll need to calculate, this should give either a true or a false value, whether we are able to eat, whether Coco is able to eat all the bananas within the given time or not, right? So the return type will be bool. The function name is helper in time, and inside this, what we'll do vector of int and percent piles, right? Then int k, that is the value of k, that is the speed that we have passed in on from here, right? And int h, that means the total number of hours that the guards will take to return. Initially, let's calculate, like here what we are doing is basically we are calculating the hours that she will take to eat bananas, like eat at a speed of k bananas per hour. So initially, let's take the value of hours equal to 0. So for each value of let's say for int pile in this piles array, what we'll check, for each pile, what we'll do, we'll divide it by the number of k, that is in each hour she'll be eating k bananas, so the number that we'll get will increase it in the number of hours, similarly how we were calculating. So int, let's say a part of that pile is equal to pile divided by k, right? Now my hours will increase by this part value. Also, second condition was ki if there are lesser amount of bananas left in that particular pile, so she will be eating those bananas in the next hour and she'll not eat anything in that particular hour. So for covering that case, what I'll do, until and unless pile mod k is not equal to 0, if there is any banana left in that particular pile, right? Sorry, pile mod k is left. So again, for that banana, let's say if 2 bananas are left or 1 banana is left, again I'll have to increase the number of hours, right? And at the end, what I'll return is I'll have to return if my hours are less than or equal to h. So this will basically tell me ki if I was able to eat those bananas in less than h hours, right? If this is the case, let's I believe we have written the code, and the complexity for this particular code will be, what would be the complexity for this particular code? So we are using binary search here. So for binary search, let's take this to be m, so it will be log m in this case. And for checking for all the piles, we are taking, like, we're moving over let's say n piles, so it will be n into the log m value of this binary search, so it will be n log m for this particular question. I hope the time complexity is also clear, and let's try to run this code if we are able to solve this particular problem, right? So for this particular case, we have successfully solved it. The output is coming out to be 4 and the expected output is also 4. I hope this question is clear now, and for let's move on to another problem, another interesting problem on Leetcode. So the next question that we're going to see is, this is maximum distance to the closest person. So what we're given in this particular question is, we are given an array that is representing a row of seats, where seats of I is equal to 1 represents that a person is sitting on the ith seat. Matlab, if there is the value of I, the value in the array is 1, so that means a person is sitting in that particular seat. If the value of seat is 0, that means that seat is empty. So there is at least one empty seat and at least one person sitting, right? So Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Return that the maximum distance to the closest person. So this is the particular scenario that they have given. Let's say this is the array in which 3 persons are sitting. One person is sitting here, another person is sitting here, and another person is sitting here. So where should Alex sit so that he is at a maximum distance from the closest person? Now maximum distance of the closest person kya hai? Matlab here it is, let's say these two are the persons. So maximum distance, what can be the maximum distance? Can he sit at this position? No, because it will be 1. Can he sit at this position? Yes, because distance from this side is also 2, this side is also 2. For this side, the closest person distance is 1. For this side also, the closest person distance is 1. So this is the seat where the distance between Alex and the closest person becomes maximum. So we need to return this seat as the output. So this is what they have asked in the question. Now let's see how we'll approach this particular problem. First, we'll try to see the brute force approach. Then we'll move on to how we can optimize this brute force approach in this particular question. Let's consider a scenario. So the question is, what's the question name? It is maximum distance of a closest person, right? Yeah. So maximum distance of closest person. Let's say they are given an array in which they have said that array is binary array, that is it has just ones and zeros. 1 represents the seat is occupied, 0 represents the seat is empty. Let's say we have this particular scenario in which we have 1 here, let's say we have some amount of zeros here, again we have 1 here, again we have 0 here, and again we have 1 here. So now Alex is a person. He needs to sit in such a way that he is at the maximum distance from the closest person, right? He should be at a maximum distance. Wherever he wants to sit, he should be at the maximum distance from the closest person, right? So what can be done in this particular case is, let's say if Alex sit here, what is the possibility of Alex sitting here, and what will be the distance of the closest person? If Alex is sitting here, let's say Alex is here, so the distance can be like, he's at a distance 1 from the closest person, right? It is 1, and he's at a distance 5 from the second closest distance, 1 and 5. But for this particular person, it is the distance 1, so it can't be maximum. Let's say at this particular position, so at this particular position Alex is sitting, so what will be the distance? 2 from this side and 3 from this side, so it will be again 2 and 3. So what is the minimum distance? Like if he's sitting here, so he will be at a distance of 2 from this person, right? So let's see if there's a better choice. When Alex is sitting here, he can be at a distance of 3 from this person, 3 from this person. At this particular point, he will be at a distance of 3 from this person, 4 from this person. It will be 4 here. It is at a distance of 4 from this 2. It is at a distance of 4 and 2, 4 from this person, 2 from this person, and for this it will be 5 and 1, right? So what is the possibility that Alex sits here? When Alex sits here, so the distance from the closest person is 1, the minimum distance, because 1 will be the distance, right? We can't take 5 because this person is the closest person to this, right? For this also, this will be the closest person, so we'll consider only 2. So answer from here will be 2. For this position, the answer is 3 from this side, 3 from this side, so the answer for this position is 3. For this position, the closest person is now this. So what is the maximum distance from this? It's 2. So we'll take 2 from this case, and for this case we'll take 1. So which according to them is the maximum distance of the closest person? The answer comes out to be 3, right? So we need to return this 3. So how we can solve this particular problem? Like for this particular problem, like this can be one of the approaches. So this is something that comes to our mind when we think of the problem for the very first time, right? What we need to calculate is we need to calculate the maximum distance of the closest person. So for this particular approach to be successful, let's consider this. Right? So for this approach to be successful, let's see what we can do. So we'll create a left array and we'll create a right array. So for left array, what we'll store the left distance, and for right array, what we'll store the right distance for this particular example only, right? So now let's say I have this only 1 0 0 0 0 0 1 0 and 1. So for this particular example, if let's say left distance, if Alex wants to sit here, so right, it is already occupied, so we'll simply mark, like initially let's just have the distance of this array, like left distance is maximum. Let's say we can denote it by int max, or we can denote it by the maximum seats available. So maximum seats in this case are 9. So let's say we initialize the entire left distance by maximum distance that Alex can be from any person is 9, right? So maximum distance we are marking it as 9. Similarly, right distance will also be of the same case. It will be 9 9 9 and 9, right? So what happens is we'll start seeing from this side. So Alex can't sit here, so we'll replace this by 0, right? So if Alex is sitting here, so what will be the closest distance from left? So closest distance from left will be 1. Here closest distance will be 2. Here closest distance will be 3. Here closest distance will be 4. Here closest distance will be 5. Here again it will be 0. Here it will be 1. Here it will be 0. So this is going to be the left array that we'll have. And for right array again, what can be the right array? So here 1 is already there, so we'll mark it as 0 because alex can't sit here. For this particular case it will be 1. Again we have 1, so we'll mark it as 0. For this particular position, what will be the closest distance? It will be 1 again. For this particular position the closest distance will be 2. For this particular position the closest distance will be 3. For this particular position the closest distance will be 4. For this particular position the closest distance would be 5, and for this it will be again 0, right? So we have these two arrays, left array and right array, right? So now from these left arrays and right arrays, what we can calculate is, first thing that we'll be calculating is, we'll be calculating an array that will give me the minimum of these, right? So minimum of these means it will be minimum of left array and right array. Why minimum? Because we need to choose the closest person. So if for this particular position, what we'll be choosing, we'll be choosing the person which is closest. Which person is closest? This or this? This person is closest, so we'll take this distance. For this particular position, which person is closest? This or this? This person is closest, we'll take this distance, right? So minimum of left and right, and for all the positions of I. And what we'll do, we'll choose maximum out of the same. We'll take a variable max and we'll calculate the maximum of either this or this, right? So solving this, what we'll get this position as our optimal position. That will, like that, this is the maximum distance, this is the maximum closest distance to the person, right? Maximum distance to the closest person. So it comes out to be 3. 3 is the maximum distance to the closest person. But let's see what will be the time complexity in this case. So the time complexity in this case will be O of n, because we'll need to traverse over the entire array, and space complexity will also be O of n because we are creating these arrays on our own. So this creates a little bit of problem. How we can improve upon the space complexity is what we are going to see in the optimized version of approach. Even if this approach is not yet clear to you, let's just move on to the optimized approach and see how we can understand the optimized approach better, right? So let us consider another case. You need to observe some of the things, right? 4, 5, let's say we have 5 zeros again, and this is the case again. So what, according to you, let's say this was the answer that was coming, right? This was the case that Alex should sit here so as to have the maximum distance from the closest persons, right? So what can be this particular position? Let's say these are zeros, right? These are consecutive zeros. We have consecutive zeros. So whenever we find certain set of consecutive zeros, what is this position? From both the sides, if we'll compare from these consecutive zeros, what we'll see is the middle element will be at a maximum distance from the closest person. So if let's say the maximum zeros in this case are 5, right? So the answer that was coming in this case is, what is the answer that is coming in this case? So the answer that is coming in this case is distance is 2, right? Why? Because when we divide 5 by 2, it comes out to be 2.5. If we'll take the seal of this, we need to take the seal of this. So taking the seal of this will give 3. So the maximum distance in this case will be 3, right? Not 2. We'll take the seal of this. Again, from this side also, if we'll measure it, it will come out to be 3. So what we can do is, like, basically my problem comes down to, we need to find the maximum consecutive zeros, and out of those zeros, I'll do consecutive zeros by 2, and the answer that will come, I'll take seal of that. So will that serve the purpose? Like, is it only the approach that we are discussing, right? Or there is something else that we are missing upon? Let's take another case. Let's take a case in which we have something like this: 0, 0, 0, 0, 0, 1. So for this particular case, what should be the ideal position of Alex? So accordingly, the Alex should be sitting here. Why Alex should be sitting here? Because this is the maximum distance, right? This is the closest person. The maximum distance that Alex has is this, right? But according to our approach, what we'll do, we'll calculate the consecutive zeros. calculate the consecutive zeros and we'll divide it by 2 and take the seal. So what if we apply the same approach here? What we'll get? 1, 2, 3, 4, 5. There are 5 zeros. 5 by 2 is 2.5. Seal of 2.5 is 3. So according to our particular approach, Alex should be sitting here. So here there is a fault. We are wrong somewhere. Right? So how we can improve upon this approach? Basically, we need to take a case where zeros are coming and these zeros are in the prefix of that array. Matlab, 1 is not there. Beforehand, there are a lot of zeros. So we need to consider it as a separate case. Similarly, let's say if this is the case, let's say we have something like this also. If it is 1 and we have 5 zeros at the end. So what would be the answer in this case? Ideal answer should be that Alex should be sitting here, right? Alex should be at the distance 5 from the closest person. But according to our approach, what we'll do, we'll calculate the consecutive zeros. Consecutive zeros in this case are 5. 5 divided by 2 is 2.5. We'll take the seal of 2.5 and we'll give the answer as 3. Again, we are at fault, right? So this is a case when we have zeros at the end, or you can say these are the suffix zeros and these are the prefix zeros, right? So for this particular case, we need to consider this a little separately. How we'll do that, right? Let's take an example and see how we can perform this question on such a case, right? So let's say I have this particular example. 0 0 0 0 0 1. Let's say 0 1 and that's it. Let's take these 3 zeros as well. Okay, so we have these prefix zeros also, we have these suffix zeros also, and we have these consecutive middle zeros also, right? We have 3 cases now, right? So how we need to handle this prefix wala case separately, we need to handle this suffix case separately, and we need to handle this consecutive zeros in the middle case separately. Right? These 3 cases are to be considered separately. So what I'll do in this case is I'll count the prefix zeros. First thing is I'll count the prefix zeros. Then what I'll do, I'll count the suffix zeros. Then I'll count the maximum consecutive zeros in the middle. Maximum consecutive middle zeros. Right? So prefix zeros in this case are 1, 2, 3, 4 and 5. So it is 5. Suffix zeros are 3. Maximum consecutive middle zeros is 1. Right? So now ideally we need to find the person should be at the maximum distance, right? If prefix zeros are there, then what we'll do, we can simply say that the person should be at the first position or the starting position of the prefix zeros for maximum distance to happen. So in this case, the answer would be 5. So for suffix zeros also, the person should be ideally sitting here. So the answer should be 3. For middle zeros, we have already calculated answer should be maximum consecutive middle zeros. We divide that by 2 to get the optimal solution. So at the end, what we are going to return is out of these 3 cases, whether there are prefix zeros available, whether there are suffix zeros available, or whether there are zeros which are consecutive middle zeros, right? So what we are going to do in this case is we are going to say maximum of prefix or suffix and my maximum consecutive middle zeros. Right? So this is actually going to give me the final answer for this particular question. That is, we need to calculate the zeros, and from these zeros we can finally conclude whether, like, what should be the exact position of Alex, right? Let's just dry run it with one more example and then we'll move upon to the code for better clarity. So let's say we are dry running it for this case in which we have like the same case that we were given on Leetcode. So the Leetcode case was 1000101, right? So this case was 1000101. So for this particular case, let's see how we can solve this particular problem. Initially, what we'll take the value of prefix as -1, we'll take the value of suffix as -1, and we'll take the value of maximum middle consecutive as -1 again. So all of these three are -1, and we'll have a variable zeros to maintain a count. Initially, the value of zeros is also 0, right? So this is the array that is given to us. The array name is seats, right? So we'll check for seats value if seats of I is equal to 0, right? So what we'll do, we'll increase the value of zeros plus plus, right? And then we'll check for cases. If the value of prefix is 0, -1, that means we are just starting up with the things. We are just starting up with the array seats. So if the value of prefix is equal to -1, then what we can do is we can simply replace this prefix by zeros in the first case, right? Like once this prefix is replaced, now this case prefix thing we don't need to change, or we don't need to consider it anywhere, right? Else what we can do is we can calculate the maximum middle consecutive zeros. So maximum middle consecutive zeros will be equal to either it will be the maximum of maximum middle consecutive zeros and zeros. Matlab the value of zeros, if it is not a prefix one, so we will check with the maximum middle prefix. If this is also not the case, then we'll simply if this case is also not there, then we'll make the value equal to 0 for each time we are changing, right? Let's say for this particular case, if it is 1, so now in this case prefix value, like initially seats of I equal to 0 is not there, right? It is just the first seat that we have. So what we'll be doing in this particular case is we'll not increase the value of zeros. We'll simply move, and we will go through this entire piece, right? The value of 0 comes out to, the value of 0 is 0. So we'll move on to the first case. Prefix value will assign as 0, and we'll move out of this case, and the value of again will put it equal to 0. Now we move to the next, that is we move to this particular part. We'll increase the value of zeros, right? Now prefix value is not -1. We'll not go into this case. What we'll check for maximum of middle values. Maximum of either max value is -1 or it is 1. So we'll compare which is maximum. 1 is maximum, so we'll increase this value to 1. Again for second zeros, the value of zeros will increase to 2. We'll again compare for 2, like 2 or 1 is greater, 2 is greater, so we'll replace it by 2. Again for 3 zeros it will come out to be 3, so maximum middle value will be 3, and after 1 comes again, so we need to make this zeros equal to 0 every time. So this 0, after this loop ends, we need to make it to 0 whenever we find a new one, right? And at the end we need to assign the value to suffix. Suffix is equal to the number of zeros if all these loops are done and we just have zeros coming in and everything else is over, right? And at the end what we'll return maximum of prefix zeros, maximum of prefix or suffix zeros, or what will be this case? This will be maximum middle consecutive by 2. Right? So at the end what I'm going to return maximum of prefix, whatsoever is maximum will return, that is the maximum distance, suffix, and maximum middle divided by 2, because we have seen that for middle case, if there are zeros in between two ones, so we need to return that divided by 2, or that plus 1 divided by 2, depending upon the zeros are odd or even, right? I hope this much is clear. So what would be the time complexity in this case? Time complexity is again going to be O of n. So why we have done this particular approach? Because space complexity here is O of 1. We are not taking any extra space in this particular question. In the first approach, we were taking an extra space. So that's why there was a problem. Now let's move on to the code in Leetcode and see how we are able to solve this particular problem through code, right? So we are given a function named as maximum distance to closest, and we are given a vector of integer seats, right? So this seats is basically a vector that is containing zeros and ones, and we need to give the maximum distance that Alex might take to, that Alex might be from the closest person, right? So the thing that we did was we took prefix equal to -1, we took suffix equal to -1, we took max middle, let's take it as max middle, it was equal to -1 again, and we were maintaining the count through this zeros is equal to 0. Now I'll iterate for this entire for loop. Int I is equal to 0, I less than seats of size of seats, and I plus plus, right? So the first thing that I need to do in this case is I'll check for if seats of I is equal to 0. If at all seats of I is equal to 0, what I'll do is I'll do 0 plus plus, that will increase the count of zeros. What will be there in the else part? Else part is interesting. First thing is we'll check for the prefix. If the value of prefix is still equal to -1, then we'll simply replace, that is the first case, we are just iterating from the beginning, right? So it will be prefix equal to zeros, right? What will be there in the else case? That means now prefix is not there, now we already have a 1 that is there, and now we are calculating the zeros which are in the middle. So right, so it is max middle, so it will be equal to maximum of max middle, and we'll compare it with the 0. So whichever is maximum, we'll assign it to max middle, right? After we are done with this, so next what we are going to do is, like, this loop is done, so we'll make the value of these zeros is equal to 0, right? Because if we encounter another one, so we need to start the count from 0 again, right? So now this is done. Like, after we come out from this loop, we have assigned the value to prefix, we have assigned the value to max middle, now suffix is left. So if at any case this seats of I equal to 0 and we are increasing the value of zeros, and it doesn't get a chance to go into else condition, that is all 0 0 0 zeros are coming. So what we'll do, we'll put suffix is equal to zeros, because all the zeros are at the end, right? So now we have suffix value also, we have prefix value also, we have max middle value also. The thing that we need to do is we need to return, what we need to return in this case is we need to return the maximum of, need to return the maximum of prefix, maximum of prefix, comma suffix, and we'll do max middle to calculate the middle of the zeros that are consecutive in the middle. I hope this should serve the purpose and we should be able to get the correct answer. So what we have done in this particular approach is the same thing that I have explained to you in the solution part. So we have taken prefix is equal to -1, suffix equal to -1, max middle equal to -1, value of zeros is equal to zeros, that is used to maintain the count. We move over to this entire seeds array, and we are we are checking if the value is equal to 0. We are increasing the iterator, that is zeros plus plus. Else we are going to prefix. If this comes out to be -1, we are simply replacing the prefix zeros value to zeros. Else we are moving that to max middle, that is the zeros which are coming in between two ones. Or if this is not the case, then we are reiterating. If 1 comes again, then we need to move these zeros to 0. So the value of suffix, so if entire loops run, so if we are just in the if statement, if it doesn't go to else statement, then we move out of this loop. We will go on and increase the value of suffix, because those are the zeros that are just coming after ones, and we don't need to do anything. At the end, we will just return the value of maximum value of prefix and suffix, and we'll see whichever is maximum, right? Whether there are maximum zeros at the middle, or there are maximum zeros at the prefix or at the suffix, and accordingly we'll be able to return an answer, right? Let me just try and run this approach. So yeah, for this particular case, we are getting 2 as the answer. So this is basically the case that we are solving here is max middle plus 1/2. That is these zeros, right? This 0. This is the answer that is that they're showing here. And I hope this problem is clear. If it is not clear, make sure you watch this video once again, this approach once again. It's a very, very important question, very, very interesting question, and you will learn a lot while solving this type of problem. So thank you so much. Let's see another problem on Leetcode. Hey everyone, so we are going to discuss the next problem. So the next problem is minimum number of arrows to burst balloons, right? So let's read the problem statement and see how we can solve this particular problem. So what we're given here is there are some spherical balloons that are taped into a flat wall that represents the XY plane. These balloons are represented as a 2D integer array. We are given a 2D integer array points, where points of I is equal to x of start and x of end. So this points array is carrying the coordinates of each balloon with x start and x end that denotes the horizontal diameter of the balloon. Matlab, if this is the balloon, this is x start, this is x end, right? So this is the horizontal diameter of the balloon. It stretches between x start and x end. You do not know the exact y coordinates of the balloon. Arrows can be shot up directly vertically from different points along the x-axis. So you are shooting down arrows from different points along the x-axis, and a balloon will burst. Like if a balloon is starting from x start and is ending with x end, it will burst if the value of x is less than start or less than end. Matlab, if we'll shoot the balloon in between x start and x end, it will burst. There's no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons in the past. Like let's say there are 3-4 balloons in a line and you're shooting up arrow from the down. So all 3-4 balloons, if they are overlapping, they will be bursted. So given an array of points, you need to return the minimum number of arrows that must be shot to burst all the balloons, right? So you need to return how many minimum number of arrows are required so that all balloons are burst. Let's say we are given this example 10, 16, 2, 8, 1, 6 and 7, 12. Let's discuss with this particular example on how we'll be approaching this particular question. Right, so now we are given this particular condition 10, 16, right, 2, 8, 1, 6 and 7, 12. So this is like, these are the coordinates of the balloons that are given, and like what they're actually going to say is, let's say we have this point that is x start, we have this point that is x end, and there is a point in between x start and x end that is x, and we can, once we shoot from the arrow, so this balloon will burst if this x lies between or equal to x start and x end, right? And also second thing, let's say if there are overlapping balloons, let's say 1 and 6, there is one balloon, it starts from here and it ends here. Also we have 2 and 8, so 2 starts from here and 2, 8 ends here. So these two balloons are overlapping, right? So if I'll shoot an arrow from here, this balloon will be burst and this balloon will be burst, so both the balloons will be burst together, right? So for both of these balloons, I'll just need a single arrow. So this is the thing that I need to keep in mind, right? Now coming upon to the approach on how we'll be solving this particular problem. So this is basically the problem clarity. I hope the problem is clear to you. It's rated as a medium level problem on Leetcode, right? So now first thing first is we need to arrange these points in ascending order, or we need to sort them on the basis of, like, how we can sort these numbers if they are in matrix in the form of coordinates. Either we can sort it using the x coordinate, or we can sort it using the y coordinate. But here sorting it using the y coordinate seems to be a little more easier and like seems to be a little more convenient. Our problem will become a little more convenient because once we know the endpoints, right, we'll be able to see if it overlaps with another or not, right? So if we'll arrange them in ascending order, let's say we are creating our own compare function, and we'll arrange them in ascending order. So it will look something like 1 and 6, 2 and 8. So we are sorting them on the basis of second number, right? It is 7 and 12, and it is 10 and 16. So now we have sorted the given array. So after this, what we are going to do is we are going to check for the numbers, right? So the first thing is, like, we'll initialize the arrow variable, right? Arrows, like at least one arrow will need to burst all the balloons, so we'll initialize the arrows by 1, and the last of any one balloon, like the x end coordinate of any one balloon. So the first element of out of this is 6, so I'll initialize last as 6. Now what I'll do, I'll run a for loop for the entire all the balloons, and we'll check for the entire points matrix, right? So for entire points matrix, what we are going to check, we are going to check if at all points of I and 0 are greater than last. That is what I'll say, like let's consider these first two cases, 1 and 6 and 2 and 8, right? So now I'll compare this last with the front of this. So is 2 greater than 6, or like 2 is not greater than 6, 2 is less than 6, right? So that means they both are overlapping. This thing tells us that they both are overlapping, right? So if such a thing happens, like if they're not overlapping, this condition basically tells they're not overlapping, so we'll not do anything, we'll simply continue. But if they will overlap, so what we are going to do, like if they are like points of I and 0, right? So in this case, points of I and 0 is, let's say if we started from here, so is 2 less than 6? Yes, 2 is less than 6. Now we'll compare 1 and 6 with 7 and 12. Is 7 less than 6? No. So here points of I and 0 is greater than last, right? So in this case, what we are going to do, we are going to do two things, right? Like in this case, we are not going to do anything. We have the value of arrow and we are just going to continue. We're not going to do anything. Now if we are comparing this and this, so now this is out of range of 1 and 6, so we'll need another arrow. So first thing that we're going to do is we'll increase the value of arrow, that is we'll need one more arrow for this particular case, and also we'll update the value of last. Now last becomes 12, right? So this is a major thing we are going to do once we get to know that two of the balloons are not overlapping. So if two balloons are not overlapping, what things we are going to do, we are going to increase the value of arrows, and we are going to change the value of last index to that corresponding balloon, that is 12, right? And we are going to do at the end we are going to return the value of arrows, and we will be able to solve this particular problem. I think it will be a little more clear to you once you will see the code for this. We'll try run the code once again, and if you have any more outside. Now this is the problem statement that is given, right? You are given find minimum arrow shots, and you are given vector of vector endpoints. Also we have created this static comparator function that compares and sorts according to the second element of the matrix, right? The corresponding second element of the matrix. So the first thing that we are going to check out in this is we are going to check if at all the points is the size of points is 0, right? Then in this case we can simply return 0 and we are done. Next is we can sort this points vector. If we are sorting this points vector, we need to sort it on the basis of the second element in that point. So points dot begin, points dot end, right, and comparator function. So this basically sorts it according to the second element present in the points matrix, points of vector end. Okay. After this, I told you we will initialize the value of arrows is equal to 1, and initialize the value of last is equal to points of 0 and 1. That is for the first case, we are going to mark the second value of the first number in the vector of vector ends. So we are initializing it as last, but in this case it will be 6, right? Yahan pe, it will be 6. So we are initializing the last value as 6 first of all, right? After this, what we are going to do is we are going to run a for loop for int I is equal to 1, I less than points dot size, and I++. Right, inside this we are going to check, we are going to compare the last element with the first element of the next balloon. So it will be points of I or 0 if it is greater than size, last. Then two things we were doing, right? We were increasing the number of arrows, right? Second thing was we were increasing the value of last. So now the last becomes points of I and 1, right? After this, what we are going to do, we were simply returning the value of arrows, and I think we are done, right? So this is basically the function, the code that we were seeing for this particular problem. Let's just try and submit on and see how it runs. It's arrows. Okay, so for this particular question, we're getting 2 as the answer because we just need 2 arrows, right? One arrow will be bursting this 1, 6 and 2, 8. Second arrow, because these both are overlapping, 10, 16 and 7, 12, both are overlapping. So second arrow will be required to shoot these 2 balloons. So basically this is how we, this is quite similar to merging intervals as well. So I hope this is clear to you. Let's see another question on Leetcode. So the next question that we are going to see is basically a medium level question on Leetcode, and it's by the name of robot bounded in a circle, right? So what we are given in this question is, on an infinite plane, a robot initially stands at 0, 0 and faces north, right? Note that the north direction is positive direction of y-axis, south direction is negative direction of y-axis, east direction is positive direction of x-axis, and west direction is negative direction of x-axis. General plane, 2D plane, in which we have all the directions accordingly for x-axis and y-axis is given. A robot can receive one of these 3 instructions, that is G, L and R. G stands for if the robot can go straight 1 unit. L means that it can turn 90 degree to the left anti-clockwise. R means it can turn 90 degree to the right clockwise. The robot performs the instructions given in the order and repeats them forever. So this is something to be considered while solving this problem. It is saying that robot receives the instructions and it repeats them forever. So you need to return true if and only if there exists a circle in the plane such that the robot never leaves the circle, right? So we are given the instruction in such a way that we have G, G, L, L, G, G. Let's just try and see how we'll be solving this particular problem. The problem name is robot in a circle. Right? So what we have in this particular question is, like, we have a 2D plane. This is north, this is south, this is east, this is west, right? And this stands for positive x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis. So this is the plane that we have right now, and what we are given is G, L and R. G stands for 1 unit forward, we move. L stands for we turn left, that is we turn anti-clockwise. R means we turn right, that is clockwise, right? So let us consider the given test case. We are given a test case in which there was something like G, G, L, L, G, G. So what happens is, if a robot follows these instructions, initial value of robot is, like, robot is standing here with 0, 0 and it is facing north direction. This is the initial position of robot given. Now G comes up, that means it will move 1 step forward, 1 unit forward, it will reach here and it will become 0, 1. We'll increase the value of y coordinate if we are getting G and it is facing north. Again we are getting G, we'll increase it by 1 more unit, it comes here and again it is 0, 2. Then it turns left. If it is to turn left, so standing here, it has to not to move, but he has to change his direction from here to here. Now he is pointing towards this, right? Again, like from here onwards, he again moves left. So he has 2 options. He can either go right, either go left. So if he goes left, so he needs to move in this direction. So moving in this direction, he again goes 1 unit down. So going 1 unit down means he is going here again again going 1 unit down, he is going here again. So that means he is going to 2 and he is coming back to origin. So this means that he is coming back to origin, right? So what we actually need to do in this question is, like, this is the scenario that I have explained how the things are working. What you need to do in this question is you need to return true if and only if there exists a circle in the plane such that robot never leaves the circle, right? So that means you have to find out whether, like, let's say there is a circle of the radius 2, 2, whether this robot will turn, maybe it will come back to its original position and it will move inside the circle only after certain sum of instructions, right? After certain instructions it might come to its same position and it will not leave that circle. So we'll check for some other conditions and then we'll generalize our result. Let's say we are given another condition of LL. Initially we have a robot standing at 0, 0. It is facing north. It turns left. L stands for anti-clockwise left. It turns into this direction. Again anti-clockwise left, turns into this direction. But he remains at the same origin. That means we can say that it is true. It doesn't leave the circle, right? Next example, let's say we take this example of GL. So when I say GL, initially our robot is again at 0, 0. GL means it moves one step forward, that is 1 unit forward, and L means that it turns leftwards. If it turns leftwards, that means it is in this particular direction now, right? So now after this, what is going to happen? Do you think that this is a case in which we should return false or true? Let us check again. There was something mentioned in the question that the robot performs these instructions given in order and repeats them forever. So if we are given a GL condition, so that means after GL is done, we'll again perform GL, and it goes on and we'll check for that. Now it has turned left. We'll go left for 1 unit, right? Now again we have left. Now this is right, this is left. Again it is in this particular direction, moves G times 1 unit again in the downward direction. It has again two options, right or left. Again it moves left and it moves to G again. Again it reaches origin. So in this case also it is reaching origin again. So that means it is not moving out of the circle and we can return true in this case as well, right? Let's take another case of GLR. Let's say we have these instructions. A robot is here at 0, 0. He's facing north. Like the first G suggests that he moves by 1 unit in the north direction, right? He moves here. Then he has an option to turn left if he's turning left, and he has an option to turn right. That means he's turning again at the top. Now again, after this instruction is done, we'll again perform GLR. If he is moving in the top direction, he'll again move 1 unit, 0, 2, again move left, again move right, then again the next instruction will be performed, again move into 0 and 3. Now in this case the robot will be going far away from the origin, right? It is going in the northward direction infinitely. So that means it will cut the circle, it will not remain in the circle, it will not return to the origin anyway. So in this case we are going to return a false basically, right? So now we can generalize and we can say that there are two things, like there are two results, or there are two conclusions that we have taken out. The first conclusion is if it comes to the origin, right? If it comes to the origin, then we can say that we can return a true. Secondly, if its direction is infinitely north, it's moving north, in that case we need to return a false. So from these two things, what condition we can make out is, if the robot returns to its origin and its direction is not north, returns to origin and direction is not north, then we can say that we can return a true, else we'll return a false. So this is the particular condition. Now let's see this particular problem in the code, and let's see how we can generalize. I've written the code for this function. We'll discuss the code on how it works, right? So as to save time upon solving this particular problem. So initially what we have initialized is the current direction, because we are given in the question that the current direction he faces north. That's why the current direction is marked as north, the value of x is equal to 0, y equal to 0, because this robot initially stands at 0, 0. After this, what we are going to do is we are correspondingly changing, or we are correspondingly increasing the value of y coordinate or x coordinate on the basis of what is the value of g, on the basis of what is its current direction, right? So we are running a loop for int I is equal to 0 for instructions dot length I plus plus. If the value of instructions of I is equal to g, that means it has to go 1 unit forward, right? So going 1 unit forward means that if its current value is equal to north, that is its current direction is equal to north, so it will increase on the y coordinate by 1. So what I mean to say by this is, like, let's say this is the robot, it is here and it is facing north. So if a g comes, it will go in the northwards direction by 1 and its y coordinate will be increased by 1. Same thing we are doing here, we are increasing its y coordinate by 1. Now if the current direction is south, then what would be the case? If the current direction is south, right, we are here only, with current direction is south, will go downwards. So again, what will happen is y coordinate will change, but it will turn into -1. So we are making the y coordinate reduced by 1, right? Similarly, if the direction is east and west, what will be the cases? So for east direction, let's say I'm currently here at 0, 0. If I want to move to the east direction, that means to this side of the plane, so what I will do is I will make 1, 0, that is I'll increment the x coordinate. This is for east direction. What will be there for the west direction? If there is west direction, then I'll again move in the leftwards direction, but in this case I'll have -1, 0. I'll make x coordinate equal to -1, and that is what I'm doing in this particular case. So once this is done, in the else part, if the incoming instructions of I, like, then we'll check for, like we have checked for g, then we'll check for NWS, right? We'll check for this incoming, basically what else can come in the incoming instruction. So after g it can be L or R, right? So for L, right, if we have L, let's say if the current direction is north, for current north direction, if the incoming direction is leftwards, so let's say if I'm currently facing north, right, incoming direction is leftwards, so I will turn towards my west, right? So now what I'll be facing is I'll be facing west. If current direction is equal to north, then if incoming is L, then I'll make my current direction to west. Similarly, we have taken all the cases. If the current direction is west and the incoming is left, so if it is west, that means it is already here in this particular direction. So if it is coming out to be left, so it will move towards the down direction, that is in the south direction. Similarly, current direction is S, that is south already. So for south direction, if we'll move left, will turn towards east. And for any other direction, that is east direction, for east direction, if it is there, if we'll turn it 90 degree, it will come out to be north, right? So these are the cases that we have written. And after this, like the final conclusion that we made, if it returns back to the origin, that is x equals to 0 and y equal to 0, or the current direction is not equal to north, in that case only we are going to return a true, else we'll return a false, right? So let's try to run this code and see if we are able to pass the test cases. Yeah, so for this particular test case, GG, LL, GG, we are getting true as the output, and that is something that they want. I hope this explanation is clear. Code might look a little bulky, but still you can, like, not bulky, but it's very easy, but the problem might look a little typical to you once you read the statement, right? So you need to solve it in this way. So if you have any doubts, do comment in the comment box for this particular question. Now let's move on to another problem. So the next question that we are going to discuss is, basically we need to calculate the minimum cost to move chips to the same position. So reading the question might look a little typical, but when I'll come to the solution, then you will say that it's very, very easy problem, right? But understanding the question and getting to that conclusion is basically what we need to understand in this problem. So we have n chips where the position of the ith chip is position I, right? So we need to move all the chips to the same position. In one step, we can change the position of ith chip from position I to position I plus 2 or position I minus 2 with the cost 0. Like if there is a chip at position I, if we increase the position by 2 or decrease the position by 2, will incur a cost 0. And if we increase the position by 1 or decrease the position by 1, will incur a cost 1. What we need to return is we need to return the minimum cost that is needed to move all the chips to the same position, right? So this is the question. Let's say in this particular question we have position 1, 2 and 3. So on all the three positions 1, 2 and 3, we need to move them to the same location, right? So if I will be moving this 3, let's say we choose any location, it can be even location also, it can be odd location also. If let's say we have an even location, right? So we need to move 1 and 3 to this 2 second position. So if I'm moving these 1 and 2 to this second position, then I'll incur a cost of 1 and incur a cost of 1. So the total cost will be 2 in this case. But if I'm moving it to one position, right? If I'm moving both of these into one position, then it will be for 3. I'll move it by 2 steps. It will incur a cost of 0. For 2, it will take 1 step. Then it will incur a cost of 1. So the answer is going to be 1 because 1 is the minimum cost out of both of them. So let's just discuss it in a little more detail on how we'll be solving this particular problem and what is exactly the conclusion that we can take out from it. Let's say we are given this particular case 2, 2, 3, 3, 2, 2. This is the kind of problem that we are given. This is the array that we are given, and we have this palette in which we have chips, right? There are 1, 2, 3, 4 chips at second position and 2 chips at third position. Now I need to move all these chips onto one palette. So it can be either 2 or 3. Right, but I need to do it in such a way that I incur a minimum cost. So if I can move these two chips to this, that is also fine, or if I want to move these 4 to this, that is also fine, but the cost should be minimum. So looking at this problem, like let's say if I'm moving this particular chip to here, so it will incur me a cost of 1 because I'm moving it by one position. Secondly, I'll move it to here, it will again incur a cost of 1. So total cost in this case will be 2, right? This is one thing, right? And also what we are given is, if the value of p of I, if we increase it by 2, then the cost incurred is 0, or if we decrease it by 2, then the cost incurred is 0. Else if it is increased by 1 or it is decreased by 1, then the cost incurred is 1. Here what we are doing, we are moving this palette from this to this, that is we are moving just one position. So if we are moving or decreasing by one position, then the cost is 1 for the first chip and the cost is again 1 for the second chip. This is what we have concluded, right? Now let's see, we can have certain generalized conclusions. What if I want to move my chip to an even position, and what if I want to move my chip to an odd position from a given PI? Right? If my given PI is odd or my given PI is even, so what will be the case? And in this also, if my given PI is odd or if my given PI is even. If this is the case, if my given PI is even, let's say I am at this particular palette, I have 1, 2, 3, 4, 5, 6, and I have certain chips here. Like I have 3 chips here, I have 2 chips here, I have 1 chip here, I have 1 chip here, I have 2 chips here, and this is the condition. Now if I move from an even position to another even position, what will be the cost, right? If I want to move 2 to this 4, so will there be any cost? No, there's no cost because p of I will be increased by 2. Or we want to move something from 4 to 2, again the cost incurred will be 0. I'll not be there'll be no cost involved, right? Similarly, if we want to move from even position to even position, there will be no cost involved. If we want from odd position to even position, let's say I want to move this 1 to 4th location. So if I want to move this 1 to 4th, what steps I'll incur? I'll incur 1 plus 2. This will give me 0 cost, right? It will reach 3 position. From 3rd position, I'll move 1 step forward and I'll incur a cost of 1. So for any movement from odd to even, it will cost 1. Similarly, in the odd case, if I want to move from odd to odd, like if I want to move this step from 1 to 3, it will take 0, no money, no cost. If I want to move from even to odd, like 2 to 3 or 2 to 5, so for moving from 2 to 5, it will be 2 plus 2, that is, it will reach 4 first with 0 cost. From 4 to 5, it will cost 1 when it will move. So for even, it will take 1 cost, right? So this is something that we have understood from this question till now. Let's say we have another example. Let's say this is the example that I have: 1 3 5 4 6 2 4 4, right? And I have this palette: 1 2 3 4 5 6, right? There's one chip at first, there is one chip at second, there is one chip at third, there are three chips at four, there's one chip at five, there's one chip at six, right? So now if I want to move these chips to one particular location, let's say if I'm moving this to, like, if I, let's say I choose an even position, it's up to me. I can choose an even position, or I can choose an odd position, but at the end the output should be minimum cost should be there, right? Let's say if we choose 4 as our output, so moving this 2 to 4 will take 0 cost. Moving this 6 to 4 will take 0 cost, right? Only these three are left. These three will take 1 1 1 each, and we will be having 1 plus 1 plus 1, that is, cost is equal to 3 in this case, right? Similarly, let me say if I am choosing this odd position, right? For this odd position, for all these three even locations, I'll have to move to 3, so it will cost me $3, and this 5 will cost me again 0, 6 will cost me again 1, 2 will cost me again 1, so for it will cost me 5, but I need to choose the minimum one, so I'll choose the 3 instead of this 5. So how we can generalize this, right? So inside this, I'll see how many positions are odd and how many numbers are even, right? And I will need to maintain a count of odd and even numbers. So like if there are as many odd numbers as possible, there are as many even numbers as possible. Once I maintain the count of odd and even, I'll return the minimum out of both of them, minimum of odd and minimum of even. So minimum of odd and even will exactly give me the cost, right? Because if I want to move from odd to odd, there is 0 cost. If I want to move from even to odd, there is 0 cost. If and only if there are how many numbers are present which are odd or even, I'll count them and I'll return minimum out of both of them. That will exactly give me the minimum cost, right? I don't need to do anything. It's very, very simple. I just need to calculate the number of odd and evens, right? If I'll be doing this, so basically how we can solve this particular problem is, we just need to count the even and odd numbers. Int odd is equal to 0, int even is equal to 0 initially, right? Then I'll write a for each loop for auto x in position vector. For each position, what we'll check, if at all x mod 2 equals to 0, that is x is odd, I'll do even plus plus, else I'll do odd plus plus, right? And once we are done with this, what we are going to do, we are going to return the minimum of odd and even. That is finally going to give me the answer, right? Just think upon this question once again on your own, try to dry run it on your notebook, then you will have a better clarity on why this is happening and how we have finally landed to the conclusion. Basically, understanding this problem was the major trick that we couldn't do, but solution wise it was very, very simple. That's why they have marked it as an easy problem. Thank you so much. Let's meet in some another problem for Leetcode. So the next question that we are going to discuss is basically gas station question. It's also rated as a medium level question on Leetcode. There are n gas stations along a circular route where the amount of gas at ith station is gas of I. You have a car with unlimited gas tank and it costs cost of I of gas to travel from ith station to the next I plus 1th station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in clockwise direction, otherwise return -1. If there exists a solution, it is guaranteed to be a unique solution. So what they're trying to say is they have given us two arrays, that is gas array and cost array. Gas array gives us the amount of fuel available at that particular station, and cost tells us what is the amount of petrol or the fuel is required to move from that location to I plus 1th location. So we need to tell from which gas station we should start so that we can travel across this circuit in a clockwise direction. If this is not possible, we need to return a -1. Let's see the approach and how we can solve this particular problem. So the problem name is gas station. So what we are given in this particular question is we are given a gas array and we are given a cost array. So gas array, basically it has like, let's take an example from the Leetcode only. It is 1, 2, 3, 4 and 5. So the value of gas available at each station is 1, 2, 3, 4, 5. Indexing is 0, 1, 2, 3, 4, and the cost to move to another location is 3, 4, 5, 1 and 2. Right? Let's say we start from this particular position, that is third index, right? So let me take a current value of fuel that is available, that will tell us whether it can go or not. Currently, initially the value of fuel is 0, it doesn't have any fuel. It starts from this third index. At third index, the gas present is 4. So this current fuel becomes 4 and it incurs a cost of 1 to move to the next station. So it moves to the next station by incurring a cost of 1. So it comes out to be 3. At this particular location, it gets 5 units of gas minus 2 units cost that is removed. 5 plus 3, 8 minus 2 gives me 6, right? So this 6 units of fuel now I have. Now from here to move to this particular location, right? So from this, now like at this particular location, now I have 6 units of fuel. Now again I will have 1 unit of gas that I have, and 3 units of cost will be removed. So it will be 6 plus 1, 7 minus 3 is equal to 4. I will reach at first index. At first index, what I'll have is I'll have 2 units of gas, 4 is the cost. So 2 units of gas will be added and 4 units of cost will be subtracted, and I'll reach the second index. So this gives me 2. At second index, I'll have 3 units of gas minus cost, that is 0. So I'll be finally able to reach the initial starting index, that is 3. So finally we are able to make a clockwise round of the gas stations. But let's say like I started it from this third index intentionally so as to show you that how it is possible. But let's say if I'm starting from this 0th location, right? If I'm starting from this 0th location, current fuel value is, so the current fuel value here is 0. As soon as I reach this 0th location, so my value of gas increases to 1, but cost is -3, right? So the value of fuels become negative. As soon as the value of fuel becomes negative, we get an indication that starting from 0th index is not possible. Let's start from this first index. So at first index, again I'll have the current fuel value as 0. I'll add the value of gas, that is 2, and I'll subtract the value of cost, that is 4. Again I'll have -2, that is negative, that is also not possible, right? After this, at this particular location, I will have, let's start from the second index. I'll have 3 units of gas, the cost is -5. It again gives out to be negative value, so again this position is not possible. So similarly we can choose from these positions available, but before that we can do a very important thing, that is one more case that we need to follow. That is, we are given a gas array, right, in which we have certain units of gas, and we are given a cost array in which we have certain like cost to move from ith gas station to I plus 1th gas station. So ideally, for this thing to happen, for a person to reach to that gas station in a clockwise direction, the total amount of gas available and the total cost, like total amount of gas available, should be equal to or more than the cost, right? So what we can do is we can add all this, we can sum of all the gas available and sum of the total cost that will be incurred. right? So this cost should be obviously less than or equal to this gas. If this is the condition, like what we'll do, we'll add all this, and we'll compare them, right? This is the case that we'll also cover in this particular problem, and we'll be able to get to a solution based upon both of these approaches. Firstly, we'll check upon whether this is true or not. If it is not true, we'll simply return -1, that this case is not possible. We can't move in a clockwise direction from one point to another in a where different gas stations are present. And after that, we'll check from 0th index, we'll check from first index, second index, third index, whichever index it's possible. Whenever this current value of fuel comes out to be negative, we'll start from the I plus 1th index, and the value of fuel at that position again becomes 0. So we'll check for at which position of the gas station or which index of the gas station we are able to come to a solution. And they have also mentioned it is a unique solution, so only one solution is possible, hence we'll be able to solve it by this approach. Better clarity would be there when we'll write the code for it. Now let's move on to Leetcode to solve this particular problem on Leetcode, right? So this is the function signature that is given to us. We have to return integer value. So this integer value, basically we need to return the index from where we should start, that we can complete the circuit. So we are given two vector of integer, that is gas and cost. Gas includes, that is the total amount of fuel that is available at that particular tank. Cost is the amount of fuel that is required to move from ith tank to I plus 1th tank, right? So this is something that you need to check upon. So what we can do in this case is int will make a variable int current. So int current is equal to 0, right? Int current is equal to 0 means that int current value is, that is the current value of fuel at any particular point of time. Initially the value is equal to 0. I'll make one more variable, that is int total fuel, right? Int total fuel is initially 0. Int total cost is also initially 0, and int start is also 0. Start is basically the index from which we are going to start, right? So these four variables we have made. Now firstly we'll calculate the total fuel that is available, we'll calculate the total cost that can be incurred, and then we'll compare both of them. For that thing, we'll run a for loop for int I is equal to 0, I less than gas dot size and I plus plus. What I'll do is total fuel plus equals to gas of I, right? Similarly, I'll run a for loop for int I is equal to 0, I less than cost of size, right, and I plus plus. Again, I'll do total cost plus equals to cost of I, right? Both of these things are done. We have got a total value of both of them, and now I'll say if total fuel is less than total cost, then I'll simply return -1, right? This is something that we have done. After that, if this is not the case, then we'll check upon starting from the first index that whether we are able to complete a circuit clockwise or not. For int I is equal to 0, I less than gas dot size and I plus plus, I'll check for current. Like what I'll add in the current value is current plus equals to gas of I. At one particular station, I can have gas of I minus cost of I. So this will give me the effective fuel that is available. If at any point this current value becomes negative, that is it is less than 0, then what I'll do, I'll start it from I plus 1 location. That location is not possible to start with, and current fuel value becomes 0 at that location. This is what I'm going to do exactly. I hope this is a very simple approach, very easy to understand, and you would be able to solve it on your own. Now let's try to submit this problem and see if we can submit it. We need to return the value of start index, right? So let me just try running this code and see if it is working. Yeah, so for this particular case we are getting 3 as the output and 3 is the expected output. So I hope this problem is also clear to you, and this was the last problem in this series. I hope you have enjoyed all the problems. Try solving these problems once on your own so that you can get a better clarity onto these lead code problems. And lead code proves to be a very important and useful platform for understanding different aspects of how problems can be solved. Most of the interview problems that are being asked by different companies are there on lead code. So practicing on lead code, maybe it's in the daily challenges or weekly challenges or bi-weekly challenges, help you a lot to understand a variety of questions, revise those concepts. So make sure you keep practicing lead code, and for any doubts in this particular video, make sure you comment down in the comment section so that I can get back to you on those comments. Thank you so much once again for being so patient listening to me in this entire video. I hope you have enjoyed this video. I hope you enjoyed this video till the end. All the problems that we have discussed are clear in your mind. Make sure you dry run all these problems on a paper and pen and try to solve all these problems on your own and submit on Leetcode. It will improve your Leetcode profile. Along with that, it will prepare you for your next interview. Make sure you hit that like button, subscribe this channel. Also, don't forget to comment below with all your doubts and queries. We'll be more than happy to take your doubts and queries. Thank you so much. All the best. Good luck.